And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.
Hey everybody, today we were debating biblical kinds, speciation, and limited ancestry, and we are starting right now. Ladies and gentlemen, thrilled to have you here for another epic debate, as we are very excited to have this interesting scientific origins debate, the kind of classic, broadly speaking, creation versus evolution. But want to let you know, we are thrilled to have you here, folks. If it's your first time here, consider hitting that subscribe button, as we've got a lot more debates coming up. So for example, tomorrow we have, does physics point to theism or atheism? That should be a fun one. And then next week, Bernie or Biden? That will be another fun one, more in the political arena. So, want to say though, today's format is going to be pretty simple. What we're going to have is roughly 12-minute opening statements from each side. And remember, this is a Lion's Den debate, which we haven't done for a while. It's basically 2-on-1. However, the advantage is more in that you could say, like, more minds at work being able to represent one side, but they nonetheless get equal time. So in other words, we're going to try to keep it such that Adam, who's representing evolution, will be getting about the same amount of time in presenting today or talking today as Standing for Truth and Raw Matt. So in other words, Standing for Truth and Raw Matt will be splitting time, roughly speaking. And with that, do want to let you know for the Q&A, if you happen to have a question, feel free to fire it into the old live chat, and then I will try to pull out each question. And if you tag me with @ModernDayDebate, it makes it a little bit easier for me to make sure I don't miss any questions. Following that, also, super chats are an option for the Q&A as well. So for example, if you want to make a comment towards one of the debaters, such as insulting Standing for Truth, fair game, all you have to do is do the old super chat, and they would of course get a chance to respond. One also mentioned though, if you have a super chat, you will also have your question pushed to the top of the list for the Q&A. We just ask, of course, though, that you actually be your kind, friendly selves for that, and whether it be a question or comment. So, with that, we are going to have Standing for Truth and Raw Matt will be going first. And so, want to say thanks before we get started, though. Thanks, gentlemen, for being here. It's a pleasure to have all of you, Standing for Truth, Adam, and Raw Matt.
My pleasure, James. I love this channel, and I enjoy discussions and debates. And Adam's a really cool guy. So we've had discussions before. I've had Adam on my channel. He's debated Ken Hovind a couple times. So I'm really excited for this. Thanks for doing it, Adam.
Oh, it's my pleasure.
Radical. All right, so we will get the ball rolling with Standing for Truth and Raw Matt. Thanks so much for being here. The floor is all yours, and I've got the 12-minute timer set for you.
Awesome. Okay, I'll kick it off. I got my timer set as well. 12 minutes. Here we go. So let's begin, guys, by asking ourselves this very, very important question. Would God have created Adam with two identical versions of DNA and Eve the same way? If this was the way God chose to do things, Adam and Eve would have created clones. And this makes no sense. God said, be fruitful and multiply, not be fruitful and clone yourselves. What makes the most sense, both scientifically and theologically, is that God created differences from the start. This is the created heterozygosity hypothesis. Adam and Eve would have had within their DNA the genetic potential to produce every shade of skin that exists on this planet or known to man. This means that another question we should ask, and this is a question I will ask Adam, where does genetic diversity come from? Because what the evolutionists I debate fail to realize and even acknowledge is the major difference between my view and their view. And this understanding is important just so we don't talk past each other. I explain the vast majority of nuclear DNA differences, not by mutation, which is how Adam here will explain them, but by pre-existing or created diversity. This one genetic difference has massive implications for the timing as to the origin of species. If you're trying to explain the origin of species just by mutations, then the evolutionists and Adam here would be right, and you would need millions of years for all these differences to accumulate. If the differences are there from the start, though, the simple operation of recombination and gene conversion and other such processes can produce visible variety in a single generation. After understanding the differences in explaining genetic diversity between evolution and creation, we should also be asking the very important question, what directly records a species' ancestry? As Dr. Nathaniel Jensen points out, the answer is DNA. Sperm and egg don't pass on a fossil or a bone. They don't pass on geography or a rock. They pass on genetics and traits. And so if we want to find out the history of humanity and the origin of species, this is where we must look. We have clocks in our DNA, for example, that go back just 6,000 years to Adam and Eve. The creationists are winning the debate, and we are winning the debate utilizing genetics. The entire junk DNA paradigm has been overturned. Orphan genes show limited ancestry. I would love to start the discussion by asking Adam here how he explains this incredible class of taxonomically restricted and essential genes. The chromosome 2 fusion has been overturned. The alleged site where the fusion supposedly took place actually represents a highly organized and functional gene. Endogenous retroviruses, ALUs, and other classes of retrotransposons, and even pseudogenes are consistent with this model of created heterozygosity, since we now know they represent functional DNA elements, not mistakes, not the remnants of ancient viral infections, but functional DNA elements. How does Adam explain the incredible dissimilarity between chimp and human Y chromosome? I'd love to get into that topic. How does Adam explain just some of the HapMap data that tells us the human genome is young and shared blocks of DNA are large? This means the genome is young and there has not been enough time to scramble them to randomness. How does Adam explain all this? These are all questions often ignored in my debates or answered, but answered incorrectly with rescue devices. Evolutionists invented the out of Africa population bottleneck that reduced the population of that time to just 10,000. Some even say 2,000 in order to explain low human genetic diversity. The low genetic diversity, the mitochondrial DNA, and the Y chromosome DNA variation all demonstrate irrefutably that we came from not just a small population, but a population of just two, Adam and Eve. I can go on and on and on. I mean, what type of selection can Adam present us, for example, that will select away so many deleterious mutations that are pouring into our genetics and degenerating our information systems? Most mutations are unselectable and invisible to selection, and artificially contrived rescue mechanisms such as synergistic epistasis, mutation count mechanism, they've been falsified. Can Adam answer any of these questions? I much prefer discussion. So in the discussion portion, Ramad and myself are happy to go over DNA barcoding and how this proves without a shadow of a doubt the limited ancestry and biblical kinds. We're going to talk a lot about biblical kinds, so I'm looking forward to that. The evidence, though, that evolutionists typically use are no help to universal ancestry, since both models can account for the data. The origin of species and the topic of ancestry is a question as to the origin of traits, and the origin of traits are encoded by genetics. Classic textbook examples of universal ancestry include homology, right? The shared structures seen in the biological world, shared forelimb structure, for example. But what we know human engineers design in homologous patterns. Vehicles from Asia, North America, and Germany all build cars with headlights in the front, 4 tires, doors on the side. Across the globe, we see shared designs and even shared blueprints. What about the so-called existence of transitional forms that I almost guarantee Adam's going to point to in his opening? Well, that is those animals that seem to blend the features of two very different species. Think of a military vehicle that blends the features of both a land vehicle and a vehicle built for the ocean. For example, an amphibious assault vehicle. This would be the perfect example of a transitional form, according to Adam here. When in fact, we know this is not the case. This amphibious assault vehicle was built and designed this way. What about the groups within groups patterns evolutionists point to as evidence for descent with modification? Nested hierarchies in DNA, anatomy, and physiology are also predicted by creationists based on the design model. The classification of life can be compared to the classification of modes of transportation and how different companies manufacture cars based on their similarities forming hierarchies, which is exactly what the evolutionists will point to in the biological realm. Um, Evolutionists will point to the groups within groups patterns as irrefutable proof that Matt and myself will not be able to point to a line drawn in phylogeny, but we're more than happy to do that in the in the discussion. So the most important thing to take from that is that these groups within groups, nested hierarchical patterns in the classification that emerges is hallmark of design. We can see that in designed modes of transportation, and these patterns are simply reflective of God's hierarchical nature. God created life in hierarchical patterns in the same way we design things with these types of patterns, modes of transportation, for example. So I'm looking forward to discussing the differentiating evidence with Adam regarding universal ancestry and limited ancestry. Brother Matt, you can take it away. We've got just over 4 minutes.
All right, sounds good. Okay, because of your name, Adam, I'm gonna go with skin color. I think skin color proves that the biblical creation model, while invalidating the out of Africa theory, because I don't think anybody would disagree that black-skinned people having an African origin. Well, if that's true, and that's the L haplogroup root where all humans came from, then that would mean that the entire world today would only have black-skinned people in it. I'll explain. Basically, you see that skin contains melanin, which is governed by either dominant or recessive alleles in genes. Now, if you carry a mix of both dominant and recessive genes like brown-skinned people do, then you contain the ability to produce all of the skin colors we see on Earth today. But if you only carry capital letters that code for black skin, then you can only ever create more dark-skinned people, just like pale-skinned people only carry lower or recessive variants. So they can only ever create more pale people. So now you can see that the problem with the out of Africa theory, the biblical model states that Noah, who was a Middle Easterner, landed on Mount Ararat in the Middle East. Well, what color are Middle Easterners? Well, they're brown. It's the only skin color that can code for all of the skin colors we see on Earth today. Thus, by invalidating the evolutionary out of Africa theory, it proves the biblical account. Did you know, Adam, your name means red skin, like Native Americans, which is brown. That's what Adam was. And think about it, Neanderthal DNA isn't even in Africans. That also destroys Africans as being the first humans, because Neanderthals are considered in the evolutionary model to have evolved into modern day humans. So that also invalidates it. But there's more. They've also have validated the dispersion of humans coming from a small group of people. Matter of fact, secular scientists themselves have determined how long ago humanity could have started from just 2 people. And to make the current 8 billion on Earth today. They discovered that every race of people could have started in 1180 AD. That's profound. That's not even what our model says. Ours even goes back further. So if secular science agrees that our model easily accounts for the 8 billion people today, then that's just even more evidence for us and how fast humanity can diversify. We posted a video on it if anybody wants to watch. It's only a few minutes. I think it's called The Study Confirms Biblical Model. Anyway, and Jensen also wanted to do his predictions because, evolution believes that out of Africa is the central hub because they looked at the diversity there and they found more mtDNA mutations. So Jensen predicted that if our model is true, that there would be more mutations in the African people based on how often they have children. They have them much more often, and there's more mutations because of that. And he predicted 1 mutation out of 3 generations, and his prediction came true. So that's probably my time, and I'm good. I'll give it over to Adam.
Thank you very much. Go ahead, Adam. The floor is all yours.
Do I have screen share going? Hold on a minute.
I am ready for you, so whenever you're ready to flip it on.
Is it ready? Is it on?
Yes.
Yeah.
Oh, smashing. Right. Thank you very much for that opening. Thank you, James, for hosting this debate. Thank you for standing, and Matt for joining me today. Right. So let's begin, shall we? My talk is going to be quite an interactive one, so you two will be getting involved with this. I hope you're ready. One thing I will say is that for your opening just then, I understand the topic is biblical kinds, limited ancestry, and speciation. I got a bit of speciation in there, but a lot of it was just attacking the evolution theory. I didn't hear much about the kinds theory, if I could put it that way. So I'm hoping when we get to the discussion phase, we'll actually start to address the main topic of the debate. Right, so this is going to be my slideshow, and as I mentioned, it's quite interactive. We're going to start with a game, and this is one that Kent Hovins does quite frequently when he's in debates. One of these things is not like the other, so I want you two to confer with each other. I will allow you to take some of my time, and I want you to decide out of the next 4 little quizzes, which one is the odd one out. So this is your first one. Any ideas?
I see a myosid on the bottom right, or perhaps a version of that on the bottom left, a hyena, a cheetah upper left, and upper right hand corner looks kind of like a raccoon. I forget the name of that. It's not a raccoon, but it's a mix. What am I looking at?
So what do you think, guys? Which one's the odd one out?
What do you mean? Compared to what? Like
Exactly. I want you to look at these and decide which one's the odd one out.
Well, I was on mute. Well, when we get into the discussion, we're going to have to look at the blueprint because we're looking at genes, traits, and genetics. That's what's inherited, sperm and egg, Adam. So in order to determine, what's related here and what's not, that's what we're going to have to get down to. That's when we can discuss things like DNA barcoding that actually does demonstrate biblical kinds and limited ancestry. So just looking at the appearance, we're going to have to look at
this all leads into a point I'm going to make later. It's just a case of give me a guess as to which one is the odd one out.
Let's go with the upper left-hand corner because everything else, if you just want to go on morphology, then the cats have retractable claws. Nothing else in that would. So,
okay, the odd one out here is the mustelid, which is the bottom right hand, is caniform, and the other 3 are feliforms. The next one. Any ideas?
Well, once again, I'm not going to just look at the visible appearance, the anatomy. I have to look at the blueprint. I have to look at the genetics to determine the odd one out. It would be like asking me, by removing the labels of a Honda Civic and a Hyundai Elantra, hey, which one's the odd man out? Well, they both are very similar in appearance. We have to open the hood and we have to look underneath. We have to look at the blueprint. So I like the game. It's fun, but I'm not going to answer just based on anatomy.
The whole point of this game was to lead into an actual point I was going to make. I'll just run through these quickly then. So the odd one out here is the tenrec in the bottom left, which is actually supposed to be more closely related to elephants than it is to the hedgehog in the top right there. These 4 here, we've got 4 reptiles, and the odd one out is the top left, which is the tuatara. It is not a lizard, and the other 3 are. Change a couple of them here. We've got 4 lizards, and the odd one out would be, I'm hoping you two would know this one. If you didn't, it was the gecko. The gecko is the odd one out here. So there's a reason I bring all this up, because there's a way that we decide what species fall into what groupings. It's something called taxonomy. Let's try it ourselves, shall we? So we've got 4 creatures here. We've got James the human. On the left, we've got a monkey. We've got an amphisbaenian, and we've got a ladybird. Now, if I were to ask you to group these based on traits of these animals, you could come up with a number of things. The first thing that might stick out to you would be legs, for example. I imagine James has legs. He can correct me if I'm wrong. Monkeys have legs, and the ladybird has legs. Now, the ladybird has 6 legs, so it's probably more distantly related to James and the monkey. And the amphisbaenian doesn't have any legs. So what if we do compare them by legs? Then we have the amphisbaenian being the out group, the odd one out. And it would look a bit like this on a schematic diagram. But obviously, there are issues here. Legs come and go relatively easily. We see this in a lot of species today, where the legs go without much difficulty or arrive. I mean, look at millipedes, for example, loads and loads of legs. So what we have to look for when we're trying to place animals are shared derived traits or shared derived characteristics. These are things that are usually quite heavily conserved in animals. And those are the ways we try to group animals into the big tree of life, as we call it. So here are a few more traits for these 4 animals. We've got legs, vertebrate, fur, jaws, lungs, the 4-chambered heart, and a tail. Most of these are quite heavily conserved. Ones that aren't are things like legs, tail, and fur, not quite so heavily conserved, but the vertebral column, jaws, lungs, and 4-chambered hearts, they don't disappear very easily or arrive very easily. Like the feathers of a bird, as far as we can see, it only evolved once. It's so specific that once it came in, it only really happened once, and it's stuck with that monophyletic clade of birds. So if we were to take a lot of these features and sort of add them all up, it would be what we call numerical taxonomy. If we go specifically for ones that are conserved, that is where we come to cladistics. And if we take that all into account, this is what the tree eventually looks like. So if we just did it with legs, it puts the Amphisbaenian as the outgroup. If we count up the shed-derived traits and look at them, look at the synapomorphies, which is another word for it, then we come up with a more reliable tree. And that's how we think animals tended to evolve. But you could just say, well, yeah, like when you mentioned cars, oh, they could just be designed that way. Well, is there another way that we can look at these animals and see if our tree that we've arrived at with shared derived traits is accurate? And genetics, that's it. So we can back this up with genetics. So if we were to look at these 4 again, it agrees with the plan that we've laid out with shared derived traits. And genetics connects all animals, not just animals, but every domain, every kingdom there is. Everything has genetics, and everything has the same genetics, made up of the same things. And the genetics we find for the vast majority of the things out there match up pretty much spot on with what we find when we compare the shared derived traits of these animals. Well, that's great and all, but what do we do with it? We can make predictions. We can predict things such as the sorts of traits we'd expect ancestral species to have. We can expect what sort of habitats they live in and the lifestyles they live. And from the genetics, we can estimate a time of divergence where we would find them. Now, the greatest example I think of this is Tiktaalik, which they predicted where it would be, they predicted when it would be, and they predicted what it would be, purely from things like genetics and taxonomy. And they found it. They went out to Ellesmere Island quite a few times because they knew if it would be anywhere, it would be there. And they found it. It is a Sarcopterygian with a neck and wrist bones. So, kinds, the main point of this discussion. I've given you what I think happens. What about kinds? What does kind do? Well, surely this is what the kinds proponents would say about the 4 creatures we've suggested, the ladybird, James, the monkey, and the Amphisbaenian. They would all be part of separate trees, part of the creationist orchard, or the kinds orchard. It doesn't line up with what we find using taxonomy. It doesn't line up with what we find in genetics, where everything is connected. What predictions would kinds produce? I've told you about one of the predictions of evolution, which is the Tiktaalik, and many, many other transitionals that we've found. What predictions, I ask of you two, does the kinds model produce? And I'm going to give you a quick analogy before I finish. Picture it like this. Life is this puzzle here, this dog puzzle, and all the little bits fit neatly together. That's how an evolutionist, as you call them, looks at it. You've got all these separate bits, but they fit together into this great big tree of life. The kinds says that those joints don't exist. They don't give a reason why. They just say that that piece of the puzzle, which should fit to that bit, doesn't fit. And then they don't explain why and start to attack the evolution theory, which is what happened at the start of this debate, where the people who are supposed to be positively affirming the kinds model just spent the entire time attacking my model. And lastly, if we look back at this example from the start of my slideshow, the evolution theory gives us the names Gakota and Toxicifera because we find the shared derived traits and the genealogies of these creatures, and we can group them. The kinds model doesn't have it, might as well scrap the entire system and begin again. So I would like the straw mats and why did I think of that? Raw mats and standing for truth. I've combined them there, portmanteau. To give me a new model, because they have to start from scratch. Instead of attacking my position, I'd like them to propose their own. And I'd like to recommend this book on the right. It's The Variety of Life. It's a brilliant book for this sort of stuff on cladistics and taxonomy. I'd also recommend reading Raw Matt and Standing for Truth and Jason Ezard, their book, 100 Falsifications for Evolutionism. It's a good bit of homework for anyone who wants to look into fact checking and sourcing. I think it's a good bit of homework for that. Thank you very much, and I hope for a fruitful discussion.
The floor is yours, everybody. Whoever would like to take it as we go into open discussion now.
Yeah, I can definitely start. I do want to thank Adam for his presentation. It was fun, and that's why I always enjoy discussions with you, because like I said, you're fun to talk to. So thanks for that. I do want to ask you a quick question, though, just to clarify. Just because I think you were misrepresenting our opening, because biblical kinds would indicate a limited ancestry as compared to a universal common ancestry. So both Matt and myself gave a number of differentiating ways that we can determine if all life on Earth is universally related through common descent, or if limited ancestry exists, as we would say, because a lot of what you pointed to was nested hierarchies, right? So whether we look at anatomy, morphology, or even physiology, Adam, both models will predict the exact same thing. So we, based on the design model, will also predict nested hierarchical patterns, these groups within groups patterns we see. But the model that I briefly touched on was the created heterozygosity hypothesis, which does make predictions. But the big difference, just so we're not talking past each other, Adam, during the discussion, can you reiterate what the big difference is between my view on genetic diversity and then your view, Adam?
From what I can see, the big difference is that I look at it as if there are no limits to the genetic variation we see. So there are no limits to the tree of life. And the way I see your position is that you have cutoff points where things are no longer related.
Well, no, I explained that because if we're looking at the origin of species and we're looking at the origin of traits, well, evolutionists like yourself assume that mutations are the source of all variety. So then you're going to reject our model, which suggests that Adam, Eve, and the original created kinds were front loaded with genetic variety. So that was technically my question. And just so we're not talking past each other and we're going over predictions and the two models, the big difference between my model and your model is that we explain the vast majority of nuclear DNA differences, Adam, not by mutation, which is how you explain them. So we just don't want to talk past each other, of course. So if you're looking for a barrier and a line drawn in phylogeny, I touched on a number of things in my opening, right? Orphan genes, which are taxonomically restricted and essential genes that I believe does demonstrate limited ancestry. So we can't look at these nested hierarchical patterns that you point to. We have to look at the blueprint, something that can distinguish between the two models. And you mentioned like conserved genes, for example. Are you familiar with DNA barcoding? And
it's conserved traits, not conserved genes.
So
for instance, the heart is a conserved trait because it's not going to go anywhere anytime fast, as opposed to, say, legs, which snakes lost or lizards are losing.
Right. So I wanted Matt to jump in here just so I'm not taking up all the time, but we do look to something called DNA barcoding, and new research using DNA barcoding has actually demonstrated, Adam, and you might be familiar with this new research, that 90% of all life has the same level of genetic diversity, meaning almost all life on Earth is the exact same age, which would be consistent with our model. And it has to do with something called DNA barcoding. Matt, did you want to? Because this will be a way we can determine, what's true, limited ancestry and biblical kinds, or universal common ancestry.
Yeah, sure. I mean, for instance, when we're standing back and we're looking at something, we would expect that something that has physical features like a primate to match us more than something like aquatic life. So we would expect the genes to be more similar because that's required for us to have these features. So we have to dig a little deeper, and that's what's great about this DNA barcoding, because they look inside the mitochondria and they found that all life on Earth has the same 34 genes in the mitochondria. One of them in particular is called the CO1 gene. And when they look at it, they find that it's highly conserved and it's always passed down in specific lineages. It's called selective sweep by the guy, I think Paul Herbert, who invented it. He's a Canadian. And what he found was that for example, when a horse, a new species of horse pops up, it's going to have the CO1 gene that its parent horse had. And so when it speciates, every single new species of horse will also have that CO1 gene. And they're gapped by little barcoding gaps. And they're single nucleotide variances that we can see and line up. And they've tracked those, and they can differentiate. You'll like this for your snakes, for example. They can find a new snake species, and they can tell how often they speciate. So we use this same model to determine what a kind is, and we can place these within kinds. One of the best ways of doing that is in 2005, a guy named Vincent Savalanian, I think that's his name, he stated that in order for any two organisms to be deemed the same species, they must share 88 to 98% of the genetic code of the chosen CO1 mitochondria gene fragment. So we're using this in conjunction with orphan genes and other things to determine what a kind is. So if you haven't heard of it, obviously I don't want to jump into studies talking about it. I just wanted to explain kind of what that gene is and why it's highly conserved and why it's always passed on.
How would you demonstrate created heterozygosity?
I think in my opening, I explained it really good with the skin color variance, because the created heterozygosity model says that the variance within what we see in the world today should have existed in the first people. And we should see loss are dead ends. And that's what we see. We see like more haplogroups in the first group of people, and then we see less today. We see more blood types in the original people. We see less today. So we see things. That's why we like the genetic entropy model, for example. But again, I'm taking standing for truth's time. Sorry, man. Go ahead.
With the thing about the position that you take, the pair of you, I assume, take, is that everything went through an identical genetic bottleneck around 4,000 years ago. Is that correct?
Right around then, yeah.
So you'd expect every single creature to show genetic bottlenecks at that point.
Yes.
And do they?
They do. They all line up in a new study that was done in 2018, and it was actually done using these DNA barcoding. And what's great is the clear genetic boundaries that they found weren't expected. And here's the thing, the genetic bottleneck didn't just exist on land life. It existed in aquatic life too. Matter of fact, the person said, in regards to it, he said, all species show the same lack of barcode diversity. Although it's easy to imagine that humans passed through a bottleneck set 1,700 years ago, it's hard to believe that the exact same thing happened in all species. Did herrings really pass through an equally recent population bottleneck, and anchovies too? They were perplexed by that because a worldwide cataclysmic bottleneck wouldn't kill all the aquatic life at the same time. So
what if I brought up, say, for instance, cobras? Now, they tested the mitochondrial DNA for cobras, a variety of cobras, and the divergence time that they got from measuring the mutation rate was over 10 million years.
That's incredible, because reptilian mtDNA mutation rates are extremely fast. So they're some of the fastest. But most likely what happens in these studies is they use a phylogenetic method. So they equate it back to the fossil record rather than just using direct observed mutation rates. But we don't like just looking at the overall mtDNA, and I'll tell you why. Because when they looked at the mtDNA sequences overall, just standing back and looking at all the 34 genes and all the mutation rates in it, they found that domestic dogs and gray wolves differed by 0.2%. But when they compared wolves of the same group in the same lineage of the same family, they found a huge 4% difference between the same population. So they found that it was kind of inconclusive. That's why they found a new way to do it, which is going inside this specific gene, which is highly conserved. The other mtDNA was too diverse, they found, to be specific. So that's what's really cool about the DNA.
Yeah. Well, when I brought up the cobras, they didn't use phylogenetic analysis to come up with the mutation rate. They just looked at the differences between known animals. They did similar things with, for instance, the Y chromosome in us. The lowest estimates for what they dug Y chromosome adding is about 60,000 years, and it's generally believed to be around 200 to 300,000 years ago. And there was a study by Chinese scientists a few years back where they took two people from the same family, two Chinese men, 13 generations apart. So they knew how many generations were between them, and they measured the differences in the nucleotide submissions in their Y chromosome. And the rates that they came up with was consistent with the other results we've had, which dates us back to 200, 300,000 years.
Well,
how would you explain that?
You mentioned that the snakes is the differences between species. We were looking at the trio methods when we come up with mutation rates rather than between species. So that could have been some of the difference. But I'll look at your study to see what you mean. And
I can come up with example after example after thousands of examples where the genetics just doesn't match up. And if you talk about the mitochondrial Eve, the mutation rate that I assume you're talking about from the Parsons paper, that was the mutation rate taken from a single Russian family. Everything else, even the authors of that paper, agreed that the estimated most recent common ancestor for mitochondria is a minimum of around 90,000 years.
Well, that Parsons study was done in April 1997, if I can remember. And what happened it was actually reevaluated the next year by Gibbons, and she not only got the exact same thing, she got even less of a mutation rate, dropping it down to 6,000. And that was published in Nature's journal. And then what happened is the FBI actually picked it up, and they still use it to this day. So they believe in the mutation rate so much, the FBI use it as forensic.
But the mutation rate does not, it doesn't give the exact year that it came. Put it this way, mutation rates differ not only between species but within smaller populations.
Well, that's what Jensen's doing. He's making predictions on mutation rates as well. He challenges anybody. He'll take you right now and go and pick an animal in the wild and predict its mutation rate. He says he can do it, and no evolutionist can.
So why then? Because it's the same process. You wanted to? Can I just finish this point before?
Yeah. Take your time. Take your time.
So the same method by which they came up with the 6,000 year number is the exact same method that they tested on the Chinese men, where the date for divergence for the Y chromosome was about 200 to 300,000 years. It was the same method. They took it from the same family and tested the mutation rates between individuals. And they came up with the rate that gave hundreds of thousands of years. Why is that wrong, but the mitochondrial Eve one is correct?
Go ahead, Standing.
Yeah, so I was just going to ask you, so for that one, I mean, we'd have to, like, for example, as Matt iterated, Dr. Nathaniel Jensen is making very specific predictions on mitochondrial DNA in people groups, for example, the Khoisan people groups, where their mitochondrial DNA rate has not actually been measured, right? Because we have measured mitochondrial rates as you're talking about here, and in non-African people groups, I think I misspoke there. In African people groups, like the Khoisan peoples, is who he's making predictions on. So have you, or are you familiar with any papers or anything that's making very specific and precise predictions on mtDNA mutation rates in people groups that have not yet been measured?
On groups of people that haven't been measured yet? Is that what you're asking?
Yeah, because Dr. Nathaniel.
No.
Okay. So, because when we use the empirical method and trace the mitochondrial DNA or even the Y chromosome DNA back to two common ancestors, we're just using, as Matt said, we're using the empirical method, right? Pedigree-based studies. And Dr. Nathaniel Jensen came out with a paper recently where he looked at the Y chromosomes. I'm not too sure if you're familiar with it, but he pointed out that if humans have actually been around for several hundred thousands of years or more, as you know, the evolutionists would say, they should have accumulated 8 to 59 times the amount of mutations that we actually currently observe in Y chromosome DNA sequence. But the researchers in that current study, they empirically demonstrated that we only observe about 4,500 years of mutation accumulation in the paternal ancestry contained obviously in the record of the human Y chromosome. And Dr. Jensen invites anybody to respond to that paper, as well as make future testable predictions on the Y chromosome and mitochondrial DNA, just as he has.
Right. I still don't understand what you'd obviously have a problem with this study by the Chinese authors who looked at the pedigree and found a mutation rate consistent with 1,000 years difference or ancestry. Why would that be a problem?
Oh, well, you got to remember that the Y chromosome, according to evolutionary mechanisms, is degraded. It's always been degrading, and they don't consider it the same as the X chromosome at all. So they have a different assumption going into it. So by going into it with the assumption that the Y chromosome is degrading 3 times faster than the X, the mathematical assumption and the model from it are all over. The discrepancies match based on what's going into it, rather than just going, oh, well, this is what we see based on the trio study. That's really not what's happening, because of the fact that they think that the Y chromosome is evolutionary falling out. They said, I think, that in 100,000 years, the Y chromosome will be completely gone. They believe that's how fast it's degrading from the populations.
Okay. If I could we move on more specifically to the concept of kinds?
Yes, and I think that's a great topic, just so we don't stay on one thing for too long. I did want to ask you, I guess, regardless of our disagreements or our differences in opinions on when this, Y chromosome and mitochondrial DNA ancestor existed, I am curious, because you seem open-minded. Why then, based on genetic data, Adam, if we're looking to the Bible as our starting point, and we're looking at human history and limited ancestry, when we actually do focus though on the variation of the Y chromosome that we're talking about here in the world today, and the fact that the Y chromosomes have very little variation, not to mention every single human being on the planet is 99.9% similar, right? That's why the evolutionists had to invent the out of Africa scenario. And the same thing goes with mitochondrial DNA, which does suggest we came at least from 2 ancestors. Regardless of our disagreements in when, how come that isn't convincing evidence to you that maybe the Genesis account does have some validity to it? Take your time.
Because every bit of evidence out there doesn't accord with it. Everything. You've given one example, which is mostly the mitochondrial Eve example, where it seems on the surface to line up with roughly 6,000 years. So that's one big example of cherry picking. If it weren't just one example, you wouldn't be talking specifically about that one example. You'd be saying, this is the pattern that we see, this is the trend. But no, you bring up one specific example because that's the only one that lines up with how you want the world to be.
Well, no, I was looking at the entire genetic structure in humans as a whole. That speaks to us of a literal Adam and Eve. I mean, that small DNA compartment, mitochondrial.
I could jump in there. I've given an example where mutation rates witnessed between Chinese men dates the Y chromosome at several 100,000 years. So that's not the whole human genome, because that goes against your point, and that is part of the genome.
Well, and that's why I countered that with the new study that Dr. Jensen has put out that I'll send to you. It's very new, and he's looked at that study as well as other studies on different Y chromosome mutation rates that points still to a Y chromosome variation and origin of 4,500 years. But I mean, like you said, maybe at this point we should just go. I was just kind of curious as to what. As to what would might convince you of limited ancestry, at least in regards to humans. So, well, if you
in order to convince me, you'd have to show me something that would convince me. If I could move on to kinds then quickly.
Sure.
What was I going to ask? I had a question in my mind. It was, oh yeah, here we go. So we're here now. Say you had a time machine and you zoomed forward in time, assuming the Earth was still around at this point. Fast forward 100 million years. What do you think life would look like?
So if we fast forwarded 100 million years from now,
Yeah.
well, I think that's actually a good question because, based on mutation accumulation, right? I mean, we know we inherit about 100 new mutations per person per generation. And based on the known functionality of the genome, most of those are deleterious. So if I were to look 100 million years into the future, I would see extinction, because that's exactly where we are heading, since there's no type of selection that can remove all these deleterious mutations.
You said there that most mutations are deleterious.
Yes.
That's not true.
Well, it is true because
most of them are neutral.
No, well, I mean, according to the assumptions of evolution, most would be neutral, but that's just because evolutionists assume that the majority of our genome is based on evolutionary leftovers, junk DNA, genomic fossils, but that's actually a direct prediction of the created heterozygosity hypothesis that would suggest that the vast majority of our DNA elements, for example, ERVs, ALUs, and these other classes of retrotransposons would be functional. And that's exactly what we're now seeing. That means the more functional the genome is, Adam.
Can I just ask quickly there? Did they make that prediction before we found that out?
Yes, intelligent design advocates have always predicted genome function increases in levels of genome function. That's why the evolutionist community attacks the findings of the ENCODE project, because Adam, the ENCODE project has shown that most of the human genome is functional, and not only that, but functional on many levels. I mean, we have layer upon layer upon layer of programming within the genome. And are you familiar with all the known functions in these retrotransposons and in the endogenous retroviruses and pseudogenes?
I'm not familiar with every single one, no.
So Dr. Nathaniel Jensen, in his model of created heterozygosity, and that's why I asked you to clarify your understanding of where we explain the origin of the vast majority of genetic diversity, for example, in the nuclear DNA, because it's two opposite expectations and predictions. I mean, how much of our genome on a percentage wise, both protein coding and non-protein coding, would you say is functional according to your model?
According to my model, I don't know. I don't know the number, unfortunately.
It is very low. Like I've debated PhDs on this, and they have to assume junk, for one, in order to counterbalance the mutations that are building up in the genome, because they need to assume that they are neutral, that they're not actually damaging the genome. But even if, and it's funny because the evidence suggests that we have a genome of function, but even if, just for sake of argument, just to not discuss this topic forever, even if I said, okay, let's pretend that the genome really is 90% junk, that still means that's 10 new deleterious mutations that are pouring into the genome per person per generation, and most of those being unselectable, because natural selection, Adam, only acts on the most detrimental of mutations and the most deleterious mutations, but it does nothing against the nearly neutral mutations. Those are invisible to selection. So my answer to your question, if we were to go 100 million years into the future, it's a very simple question. I mean, life would not exist. And I guess you would have to explain how natural selection can keep life in existence for that long. Go ahead.
Yeah, you talked about genetic entropy. Now, I looked up genetic entropy, and the only places I could find it on Google Scholar were creationist sources, specifically from John Sanford. And all the examples I see are very specific, species-specific examples, mostly humans. Now, the problem with humans in the natural world is that we've sort of done away with natural selection. So, yeah, deleterious mutations are more numerous than beneficial ones. So over time, if there is no selection pressure, you'll have more of a buildup of deleterious mutations. However, natural selection in the wild, assuming that it's able to do what it needs to do, will prune the wild populations of deleterious mutations and keep the positive ones. So that's how you maintain populations. That's what natural selection does. It gets rid of the bad and it keeps the good, what's fit for the environment that the creature is living in. That's how populations are sustained, and that's how they have been sustained.
Right. I really appreciate that response, because you made some good points. I just don't think that you've addressed the nearly neutral mutations that would build up, because the same thing goes, and I don't want to take all the time. I know Matt has some good examples of genome degradation, and health, for example, is kind of his specialty. So I'll let him take over in 1 second, but I do want to point out the fact that, in humans, so obviously you're admitting that we are degenerating, but you are saying that it's due to a lack of natural selection, right? Which makes sense, but it would come down to, let's say, animal populations. It would still come down to genome function as a whole, because even in animal populations, they still have to assume that the majority of the genome is junk in order that the junk areas can absorb the mutations, making them neutral. But the fact is, Adam, and you have to address it, is the evolutionists has lost one of their favorite pieces of evidence, which is not only junk DNA, but also the presence of these ancient deactivated viruses that they say are in the genome. Because rather than being functionless vestigial remnants of our past, these retrotransposons, as a direct prediction from our model, turn out to be functionally integrated into the amazingly complex regulatory genetics and genomes of mammalian genomes. So that means that total functionality with all these DNA elements, DNA sequences, will speed up and make the degeneration problem that much worse in humans and in animals. Take your time.
I am very curious, because you keep saying that intelligent design predicted. Who predicted it and when?
So there have been predictions in the past. I can get you specific names. For example, Dr. Jonathan Wells has made those types of predictions. Dr. Nathaniel Jensen has in print right now new predictions that the vast majority, over 80% of our genome, because ENCODE, they did what's called biochemical tests, right? So Dr. Nathaniel Jensen predicts that using genetic knockout tests will reveal exactly what types of functions these DNA differences have. Because if we predict that the vast majority of DNA differences are actually functional, Adam, that would be evidence for that exact hypothesis. We're seeing that with the overturning of the junk DNA. I mean, what was called junk DNA, we now know can modify the way chromosomes, right, the packages of DNA, are organized. And then what that does is it changes the way the DNA functions. It's DNA function on multiple levels. I mean, how do you address all that?
Non-coding areas of the genome do exist in large quantities. And in fact, it's one of the ways that you get de novo genes, which explains orphan genes. So for example, a study recently looked at cress, several species of cress. And they found that these lineage-specific genes, or what they call orphan genes, were actually just mutations of non-coding DNA that didn't do anything in other species of cress.
Right, and that's the assumption. So
no, it's not an assumption. They tested it.
Well, no, I understand that, you know, the explanation for these taxonomically restricted and essential genes is de novo gene synthesis. I'll address that in a second, but I wanted to point out that if the genome truly is junk in the non-coding region, most of it, you know, has no active role. But then the ENCODE project has revealed that over 80% of it is actively transcribed into RNA, and the evolutionists say, well, that's just biochemical testing. But my question to you would be, if it truly was junk and there was no useful activity there going on in the non-coding regions, why, Adam, would the cell even bother with it? Because wouldn't you agree that that activity that is discovered would be just a waste of energy and resources, and natural selection, which we were talking about earlier, should have eliminated that junk long ago, according to evolution? How do you answer that?
I'd have to look into it more. I couldn't answer off the top of my head without sounding like a complete dunce.
No, that's okay. I'm enjoying it. I do want to pass on to Matt real quick, because his expertise on health and genetic degeneration, I wanted him to at least point out a few examples.
interject something here. I would like to eventually get back to kinds, because we keep drifting back to evolution stuff, and your
I
idea
have
is
to
that
disagree.
disprove evolution.
Well, no, it's not disproving evolution, because, and I know that the assumptions and basic worldviews of evolution, it's hard to, put themselves into the mindset of a creationist, because what we're saying is that the vast majority of DNA differences were the result of divine creation. And evolutionist says it's mutations over time. That means we have two very different expectations and predictions on ancestry. You would expect, a genome of junk, evolutionary leftovers, and genomic fossils. We would expect a genome of function and DNA elements. That's what's going to help us determine whether or not everything's related, or whether or not limited ancestry, according to the Bible, is what's true. And that's exactly what we're pointing out here and demonstrating.
Okay.
Is that
so what could you explain then why every creature, if you test them genetically, comes up into this well-defined tree?
Right, and that's a good question. You're going back to the nested hierarchical patterns, the groups within groups patterns that we see in life. And as I pointed out in the beginning, the design model predicts and expects the exact same thing. That's why we have to look at differentiating evidence, which would be function. How do we test, for ancestry? It would be function, a genome of function versus a genome of junk. But like you said, let's go more into kinds and more expectations of speciation from, say, the original kinds, because I know that's what you want to talk about, and I think that would be enjoyable for the audience. But can we just reserve just 1 second for Matt to jump in and make a point about genetic entropy, and then we'll go right to kinds and definition of kinds and things like that?
Yeah, that's absolutely fine with me.
All right. I'll just get it over with real quick. A perfect example is a video that I made, which shows Neanderthal. It shows that they have less overall genetic mutations in their entire genome, and today we have a lot more. We also have something called the MTHFR gene, and it's broken anywhere between 40 to 70% in almost all people on Earth. And it's that gene determines on how well you methylate and how well your other genes work and how good they are. So it kind of shows a genome collapse by looking at that. But, that doesn't really have much to do with kinds. It's just an overview of showing that the genome is kind of crumbling and breaking down. We see gene loss. We don't see new genes arising and our genome going up. We see it going down in all life. So
I will just put a point on that. We do see genes arising. I mentioned the CRESS earlier, where they identified many non-coding sequences becoming de novo genes. So we do see increases in genes. We also see anatomical increases, which are results of genes. So for instance, dogs, more primitive dogs, wolves and huskies, don't have puppy dog eyes because they lack two muscles around the eyes, whereas more recent breeds of dogs have these muscles, and that is a result of mutations that came about to benefit dogs that live with us because we love puppy dog eyes. I think that's a beautiful example of evolution in action that happened during human history.
But these de novo genes that are arising spontaneously, kind of like out of nowhere, that really are considered junk DNA, are actually functional elements. So we can't just say that these are randomly arising, but yet these de novo genes are absolutely required for functions in the gene in the body. If they were just, that's what makes the orphan genes so fascinating, is because they're lineage specific. So it also helps prove our model a little bit because they are taxonomically restrictive genes, but they're also functional elements, which Standing mentioned earlier.
The fact that genes become active from non-coding genes, I don't see how it proves your point. I don't see how it lines up with it.
And I like your point on orphan genes, Adam, but we would just have to see actual, papers that are showing a non-coding region of our genome suddenly popping up and having an incredibly functional role. Because
if you look at the one on CRESS, it was quite recent. If you look up CRESS de novo genes on Google Scholar over the last, I think it was 2016. If you look at it, there's about 500 de novo genes that come up from non-coding regions.
And we have looked at many papers. I just want to put this out there, is that in what you're saying, just to reiterate, these orphan genes were created supposedly from just random mutational events in the non-coding regions, and they've now co-opted function in the protein coding regions. They're not right. Is that how you would explain the orphan genes?
We see the non-coding regions. The reason we didn't see them before is because they were non-coding, so we didn't really know what we're looking for. But when we found these genes in this certain species of cress, we looked back at other species of cress and checked for that same sequence and find that it's a non-coding region of the DNA.
Well,
I'm saying cress. I'm assuming you think cress would be within the same kind.
Right. Well, and I'm just saying, I'll give you plenty of time. I'm just saying that because evolutionists reject this concept of engineered design in biological systems, when they see the presence of these taxonomically restricted orphan genes, they have to come up with a way as to how these cleverly, designed DNA sequences were somehow randomly generated in very recent evolutionary time, and you look to de novo gene synthesis. But my response to that would be that it's based more on a circular argument, because evolutionists say, okay, de novo gene synthesis must be true because why? Orphan genes exist, and orphan genes exist because of de novo gene synthesis. So I don't know how
there are various methods for not de novo genes, orphan genes. You've also got things like fission and fusion of genes. You've got gene duplication and exon shuffling off the top of my head.
Right. But a lot of times in these papers, for example, one that Matt and myself are really familiar with are the so-called introduction of new orphan genes in fruit flies. Matt, did you want to touch on that real quick? Because orphan genes, you must understand, for one, could be lost as well, which could explain why you're seeing some in some species in the same kind that other species in the same kind don't have. Did you want to touch on that real quick, Matt?
Yeah, real quick. They took fruit flies and they looked inside of their orphan gene status, and they wanted to try to get them out. So what they did is they bred fruit flies, a specific species of them, to have 0 orphan genes in their bodies, just to see what would happen. So they bred them entirely out after maybe 10 generations or so, completely gone. So the flies were living without any orphan genes in their body.
Okay, I just want to make a correction. I said 2016 for the Cress paper. It's actually 2011. So if you wanted to search on it, it's a paper from 2011. Could we move on to kinds then? I don't know how much time we've got left, but
let's do that, because I did notice even in the audience, they're saying what's the definition of kind, and I know that you've asked that many times.
I think that's a great way to start. I would love to hear your definition of kinds and be able to apply it suitably.
Okay, so I would say that my best definition of kinds would be groups of living organisms, Adam, that belong in the same created kind if they have descended from the same ancestral gene pool. So I think if it comes down to inference, for example, we can infer with pretty good certainty, Adam, that dogs, wolves, coyotes, and foxes all go back to an original ancestral gene pool. But we cannot scientifically infer that dogs, wolves, pine trees, and banana plants go back to an original ancestral gene pool. I want to make one last point, and you can talk as long as you want. Just like Matt iterated earlier and explained about the DNA barcoding and the CO1 gene in the mitochondria, that research demonstrates that 90% of all life has the same level of genetic diversity, meaning almost all life on Earth is the same age and came into existence, well, in our model, according to the flood, at the same time. That DNA barcoding puts a line in the phylogeny, which is exactly what you'd be asking for kinds. Take your time.
So your definition, put simply, is if they descend from the same gene pool. Is that correct?
Yeah, that's good.
How would you demonstrate that?
Good question. So we would use, as Matt kind of talked about earlier, the DNA barcoding. We could use that. We can use, it's a variety of things. It's a trio of things. We can look at orphan genes. We can look at taxonomically restricted endogenous retroviruses, DNA function, and most importantly, we can actually look at species, and we can look at their speciation rates, because Dr. Nathaniel Jensen has made very specific predictions on speciation rates, and we can see if that fits empirically with the original kinds coming off of the Ark just 4,500 years ago. We can look
in order for that to work, you'd have to know how many kinds came off the Ark, wouldn't you?
Right. So I mean, well, we can do.
So that's circular reasoning there. You'd see how many speciation events you'd need according to how many kinds came off the ark in order to find how many kinds came off the ark?
Well, the thing is, we would have to make hypotheses, for example. Okay, so if we look at, let's say the cat kind that came off the ark, or the dog kind, or even the bear kind. Okay, if we go back to this idea of pre-existing diversity, okay, this means, and I think after we talked about it for a while, you understand it now. This means that God created Adam and Eve and the kinds with differences within themselves. Okay, so that hypothesis can apply universally among species. So if we take the cat ancestor aboard the ark, okay, let's say that cat ancestor was front loaded with a whole bunch of functional DNA differences at creation. These front loaded functional DNA differences has led to the origin of species. So Noah brings aboard 2 cats, Adam, and now we have everything from tigers to house cats to jaguars and in between. Or with dogs, Noah brings 2 dogs. Now we have everything from wolves to coyotes to jackals to foxes and in between, and ultimately the domestic dog.
But you've got no evidence to say that that's what happened. It's just a post hoc rationalization. Right. Even though we find that genetics says that we have common ancestors for, say, cobras 10 million years ago. That's all within genetics.
No, and that's a good point. I'm just explaining how it's possible to get all these numbers of species and how we can explain because if we look at, for example, you got kingdom, phylum, class, order, family, genus, species, okay? So we would say, according to the biblical view, that God created kinds, which would be more so the family level, not species or genus, but family. Now I'm showing you how that's possible to get all the ancestors and all the species from some kinds on the ark. Now we make predictions to see if this lays out, because a hypothesis without any testable, falsifiable predictions would be failed. It wouldn't be science. So that's why we've made we can look at snakes, for example. I know Matt's got some numbers on that. We can look at birds. We can look at lizards. I don't want to take up all the time, Matt. If you want to take this next part and go into the actual speciation rates of snakes, which is kind of that's Adam's field, or birds, for example, and go over the hypotheses there.
I'd love to talk about snakes.
Sure. Okay. All right, then we'll just go with snakes. Well, I guess we'll go with a couple different things at the same time. If the speciation rate of snakes shows that it's about 1.2 per year, and we extrapolate that back about 4,350 years, somewhere around there for Noah's Ark flood, we should see around a variety of snakes which is associated with that type of speciation rate number. But if evolution was true, even going back 1 million years would have somewhere around 1 million snakes, even though that would be even more, because we have to account for some extinctions. But I mean, snakes are found back 167 million years, and snakes are very hardy animals. They do really good. Matter of fact, even if you go back to the fossil record, the evidence of intermediary fossils between these snakes and lizards really aren't even there. All of a sudden, we just have snakes, and then all of a sudden, there's just lizards that are snakes that don't have any anatomical features as the snakes. So the snakes appear randomly, and then all of a sudden their speciation rates don't match the pattern of how many snakes there should be in the world today if their speciation rate that we see today doesn't match up at all. Our model fits much more clear with what we see.
Okay, I remember reading this, I think, from your 100 plus falsifications evolution, the 1.2 figure. And I tried to look up that source, but I couldn't find that figure. So if at some point you could pass that on to me. That is, I don't even remember what group of snakes it was from. You mentioned there are no intermediary snakes, but I could name a few. Tetrapodophis, which was a 4-legged snake. Najash, which was a 2-legged snake. And you've got the Annelidia. I can't pronounce some of these, but it's a snake with a jaw like a lizard. And that's the same with Coniophis, which again is a snake with a lizard's head. And these are all roughly around the time that they were supposed to have diverged from lizards. They still are lizards. I mentioned this in my opening. You have to scrap the entire idea of taxonomy because it just doesn't work in your model. Snakes are lizards, but I'm assuming you don't think that, even though genetics and cladistics puts them in the same group. Snakes are a type of lizard. So we have in the fossil record snakes with legs, snakes with lizard-like jaws, snakes without the ventral scales. So one of the more defining features of more advanced snakes is the single scale down the body. We have snakes alive today that have cylindrical bodies with scales all around without the ventral scales. There are plenty of examples of intermediary snakes.
Well, did you realize, though, that that goes actually contrary to what snakes need to be in your fossil record? The oldest snakes that go back 167 million years ago, they found 4 different varieties, and none of them actually had legs. So if they evolved losing their legs, we would see that transition. We see the opposite. We see snakes with no legs, and then all of a sudden some snakes that have just hind legs, and then all of a sudden one variety that had some vestigial front little tiny remnants, and then back to no legs again. So that's the opposite of.
I mentioned at the start of my talk that there are some features of animals that are very easy to lose. Fish and snakes lose eyes in caves. Legs are one of those things that just so happen to be one of those things that are easy to lose.
Yeah, but
and you have the idea of sister species as well. So when the snakes start to diversify, there'll be loads of different groups of these snake-like lizards going around. Some would lose legs quicker than others in different environments, and you'd have this whole cluster. I mean, you have it today. We have lizards today that have no legs. We have lizards that have 2 front legs, and we have lizards that just have stumps where their legs should be. They're very easy to lose.
Yeah, but the very first snake that you find in your fossil record goes back that has any back limbs is 20 million years. But yet the oldest snakes, when supposedly split from a lizard, have no legs at all. That go back to 167 million.
Now, so I'm pretty sure I mentioned Tetrapodis. I think that was at least 100 million years. Najash as well was ancient, and that had legs as well.
But the oldest 4 varieties, again, had no legs. There was nothing there. And that's the oldest, deepest part of the fossil record, which should have the highest amount of vestigial leg bones present because they're the first transition from a lizard, but there's none.
You say the first transition from a lizard, the first known one. There would probably be a lot of populations of lizards before that had started to lose their legs. Just because the first example of a snake we find doesn't have legs, it doesn't mean that they didn't evolve. But let's get back to the main point. Are snakes part of the lizard kind?
No, because we find that on the DNA barcoding level, they are separated. We find they have different barcoding gaps, and any barcoding gap that is too large will place them into a different family. Now, DNA barcoding is the first time they've ever been able to use it on a species level, so that's all they use it on, but it works in larger conjunctions. That's why that guy in 2005 determined if the gap is above a certain amount, what was it? Yeah, there it is. If the gap is anywhere between underneath 88% of genetic code variances with a mitochondrial fragment, then it's a different kind. It's a different species altogether.
Yeah, throughout this debate, I've not mentioned. I don't know much about this DNA barcode. I realize it's been mentioned a lot of times, and for the most part, I've tried to just avoid it too much because I don't know much about it. What I do know is that snakes, when compared to lizards genetically, fall between. They're close to the iguanas. I showed you the picture earlier with the gecko being the outgroup. A gecko is further related. A snake and an iguana are closer related than either is to the gecko. Do you think that geckos and iguanas are the same kind?
I would say no, because some varieties of geckos don't even eat food. There's one variety that doesn't eat for like its entire lifespan. It just absorbs things through its skin, and it seems to me as though they're very different.
I seem to get the impression that you think that because there are differences at the gene level or behavioral level in some animals, that means they're different kinds.
Well, remember, for us to be related to an aquatic species, there would have to be a lot of not only just the same genes, but the same function of these genes. That's why Standing for Truth is saying that the function is what matters. That's why this selective sweep gene is so important, because it does the same thing in every species. So when it's passed on, you can find this little teeny little bit of difference between species, but a big difference between kinds. So that's what's really fascinating to us.
And the thing is, and Adam, that's why it's okay if you're not up on the DNA barcoding, but in order to draw a line in ancestry and in phylogeny, where nested hierarchical patterns exist in anatomy, genetics, and physiology, it's going to take and require some type of differentiating evidence. And this new study and the analyses they've done in barcoding, in DNA barcoding, really has revealed gaps, huge gaps in these species and in families, and it's consistent with limited ancestry, special creation, and in biblical kind. So that's kind of the point of the DNA barcoding. If you want to respond to that, that's fine. I do want to ask you a question afterwards about more so speciation rates according to the evolution model, but you can respond to that first if you'd like.
Yeah, again, I think if we have another discussion, I'm going to look up this DNA barcoding and come up with it, because that seems to be what you're falling back onto now. And if I can't address it, then we've hit a bit of a standstill on that point as far as I'm concerned. I do want to ask, what kind does Tiktaalik fall into?
I don't know if anybody's ever tested it, just because it never popped up on the radar. It can be tested if there's enough genetic evidence or material in the bones. For example, they've tested Denisovan and Neanderthal and compared it to human beings. So if they're able to extract it from Denisovan, then I'm guessing they can do it from Tiktaalik. I just don't think that that's been on anybody's radar. No,
I don't think you're going to get much genes from Tiktaalik.
And that's the problem, is that it's, what's inherited, sperm and egg, as I iterated a few times, it's genes, it's traits, it's genetics. That's why when we're looking for an answer to ancestry, a fossil is not inherited, Adam. Geography is not inherited, it's genetics. We have to look at the gene level. And that's why we look to DNA barcoding. That's why we look to DNA function is key, as well as certain taxonomically restricted genes, including the endogenous retroviruses and other things like that. But we have discussed that in great detail. So just according to your model, though, when it comes to speciation, what would be a prediction or expectation that you would have regarding speciation rates and speciation events? Like, does it take millions of years for speciation events to occur, or can you go into that a bit?
Speciation takes as long as the environment requires it to, because speciation tends to happen when a new niche is opened or a niche is vacated by another creature. So that's what the whole basically punctuated equilibrium thing was all about, where not much can happen for a while if the environment's in a pretty stable condition. But if something big were to happen, say a volcano were to go off and radically change the environment in some near vicinity, then you'd have a lot of adapting to do. Now, adapting a lot of times can lead to speciation. So it's not a constant rates thing. It's very much dependent on what's happening around these organisms at the time.
Now, would you say that the average speciation events, would take millions of years, like on average, according to the evolutionary model? Because obviously, according to our model, it's completely different expectations and predictions, because we're expecting all these species in just a few thousand of years, and you would be expecting all these species in hundreds of thousands to millions of years.
It's not something you can really put an average on, because it can depend on a whole host of factors. Generation time can be a factor. The rate of mutations in certain parts of the genome, because that rates differ across the board, that can be a factor. The speed at which organisms diversify, it could be not down to genetics if something reproduces or not. It could be down to size of the organism. Do you think you're going to get a Great Dane to mate with a Chihuahua without artificial insemination? If humans disappeared and every breed apart from the Great Dane and Chihuahua disappeared, would they be the same species?
Ask that again real quick, Adam.
If humans died out, say coronavirus kills us all,
right, and
every dog breed apart from the Great Dane and the Chihuahua survived, would they be a new species?
No, because you could, like you said, artificially inseminate them.
Yeah, but we're not. We died. Coronavirus wiped us out. Artificial insemination doesn't happen anymore.
Yeah, no, they would be, because there you go. We go back to DNA barcoding. We have to look at the blueprint. We have to look under the hood. I can't look at a Civic, an Elantra, a Jetta, and a Chrysler 200 and determine where they came from, who engineered them, without looking at the VIN number, the blueprint, the details, the engine, for example. You can't just look at the car.
The big difference with cars is they don't have shared derived characteristics, which is how systematics works. Because a car, you can put anything on a car because they're made by people. We know how cars are made. We make them. We know how organisms come about. They reproduce and they go through genetic recombination. So they can't just add a spoiler. They can't add a boom stereo in the boot. They're restricted to what genes bring about. Cars, we make them, we change them. If we were to put cars into a systematic diagram, if we were to try to make cladistics out of cars, depending on their features, it would be a mess. And that's why you cannot compare the two.
Well, no, it wouldn't be a mess, just as I demonstrated in the beginning, that it just so happens to turn out that designed modes of transportation that humans have designed and built, they do naturally fall within groups, nested hierarchical pattern, whether you like it or not. And those patterns, Adam, can be seen both at the visible level and at the blueprint level. And according to our model, if God created us and made us in his image, then we should be able to get a sense or an idea for how he created life based on the things that we create. And we create. I'm almost done. I didn't interrupt you. We create modes of transportation, and you can see this with sedans, SUVs, vans. You can go all the way to airplanes and boats, and the materials that are used, they fall within groups patterns. And evolutionists often do say that cars don't reproduce. Well, for one, that's a misunderstanding of the design model and the predictions that flow from it. And two, adding reproduction adds complexity, and that actually is no help to those that hold to universal common ancestry. Take your time.
So if we were to try to look for the synapomorphies, the shared derived characteristics of vehicles, so for instance, we've got a bicycle. Bicycles don't have engines, do they? So your typical pedal bicycle. Cars have engines. I assume you'd say then, well, not just cars, but lots of vehicles have engines. You'd say that an engine would count as a shared derived characteristic.
Well, no, you can make a list and compile and classify all modes of transportation that are powered vehicles, and then you can have a separate class or a separate group or category of non-powered vehicles, which bicycles would fall into. But even if you look at the if you look at the microscopic level, if you look at the materials used, the metals used, you're still, just like in DNA, you're still going to find nested hierarchical patterns. I mean, this is just a fact. You can't get away from it. That's why we have to look at, Adam, differentiating lines of evidence, DNA barcoding, DNA function, orphan genes, the number of DNA differences. But the thing, and we can go back to that, but I don't want to just go too far away from the species thing. So I was just trying to clarify some things, just to make some points on the speciation.
Yeah, I didn't finish my analogy, so I'd like to go back to that. Okay,
finish it. Yep, go ahead.
So the bicycle, the pedal bicycle, does not have an engine. Hold on, excuse me. The bicycle does not have an engine. So if we were to make a big cladogram of vehicles, bicycles would be in the section where the engine wasn't a shared derived characteristic. My uncle put an engine on his bicycle, a pedal bicycle, and zoomed down the road. So that shared derived characteristic is no longer a shared derived characteristic because somebody put it on a bike. That's why the systematic diagram for vehicles would fail, because it would be a complete mess. Anyone could put anything on anyone. A rabbit does not grow feathers. You can't nobody just puts feathers on a rabbit. And that's why there's this big difference, because it's all about inheritance, things you inherit. That's my answer to that. And that's why I think the cars example fails completely.
Well, see, the thing is just basic observation on modes of transportation. And I understand that, evolutionists don't like the fact that modes of transportation, without even meaning to do so, they do actually fall within nested hierarchical patterns. Maybe you can point out some inconsistencies, just like I can point out some inconsistencies in the phylogenetic tree of life. Because although there are nested hierarchical patterns in life, both on an anatomical level and a genetic level, there are inconsistencies. That's the whole point of, incomplete lineage sorting. Depending on what gene you're looking, creates different types of trees. You can look at convergent evolution. You can look at many different types of inconsistencies in the phylogenetic tree. But according to our model, if we do predict some type of nested hierarchical patterns in DNA and in anatomy, it makes sense, because even if we look at, let's say, humans, pigs, mice, and ducks, okay, so we would say they are all land dwelling, but we would also say that they are all of separate kinds. But since, Adam, they are all land dwelling, they are going to share similar nested hierarchies or designs. There's always going to be some type of hierarchy. And like I said, I've said it many times before. That's why we have to look at a line of evidence that is going to be able to differentiate the two models. Is it okay if I go to the speciation question, or but take
yeah? I just want to once again say I don't like the use of the word prediction, because nested hierarchies have been known long before any of these people in the intelligent design movement came about. It's like me going to a football game, watching the game, coming out and saying, I bet Lionel Messi is going to score 3 goals after having just watched him do it. It's not a prediction. It's an ad hoc rationale.
One thing
that's just one thing I wanted to
One thing, standing for truth, before I'll give you a chance to respond standing for truth, but just wanted to quick jump in and say, first, I forgot to mention at the start, folks, that I have put all of our speakers' links in the description. So highly encourage you, if you're listening and you're like, I like that, well, you can hear plenty more by clicking on those links that I put in the description. Also, just want to let you guys know that maybe pretty soon we'll probably go to Q&A. So I'll kick it back over to you, Standing for Truth, if you want to respond. But maybe I would say, if you guys are ready, especially because if I remember right, Adam, you might have to get up in the morning, or you want to get to sleep by a decent time. So
unfortunately, I don't work at the moment because coronavirus won't let me, so I'm unlimited in my time.
You bet. Okay, gotcha. Well, I'm pretty unlimited on my time as well. So if you guys want to go for, we can go longer than usual if you guys want to go for like another 15, 20 minutes and then Q&A.
Yeah, maybe do a strict 15 minutes of discussion more, and then Q&A. I would like to go all night, but I've put my kids down for a nap for the debate. And once we come up the 2-hour mark, they're probably going to get up, and that's going to be an issue. So
barge in there.
Okay. Barge in there. My daughter, who's 4, if you want to debate her, Adam, we can set that up.
Very sassy. All right. Thanks very much. Go ahead, Standing for Truth.
Okay, awesome. You know what? I am tempted to go into convergent evolution and all the detailed inconsistencies and lines of evidence that show a lack of uniqueness in the phylogenetic tree, but it would probably just take up the rest of the 15 minutes when I do want to get to more of I think an important line of evidence that can show biblical kinds in regards to speciation. So if we move, so let's say we move to species, okay?
Sure.
We do make predictions, very specific predictions, not only on the DNA function, for example, but also and mutation rates, but also, and you can see these in print, Adam, but also on, like I said, speciation rates. So even if we look at the 30 or so species of cats alive today, well, just to keep it simple, that would make prediction. It would make a prediction that cats, for example, have been forming at a certain number of species per year, or it takes this many years, for example, to form a new species on average, according to our model, and that's why we've made very specific predictions on speciation rates. That species are continuously forming, and you admitted that the evolutionists can't really make those types of predictions, but the thing is, we've made them on birds, for example, and you can look, and we've got the numbers here. You can look. There's about 11,000 or 12,000 bird species alive today on the planet. So Dr. Nathaniel Jensen has made a prediction that if we take this observation and predict that since the time of Noah's Ark, there's been about 3 to 4 new species on average per year. We should be able to see new bird species forming today. And that prediction works out because if you see, so let's say there's 11,000 bird species on the planet today, that's about 4,500 years since the flood. And of course, if you do the math, that's 4,500 years since the flood, 3 or 4 bird species a year would actually work out perfectly if you do the math, and those predictions are in print. But we've actually seen just this past year on the Galapagos Islands, Darwin's finches, for example, they've been studying for a number of years. New species, Adam, have actually been observed, and those results have been published. And those species were formed in exactly the same way that Dr. Nathaniel Jensen predicted that they would be formed. For example, shifts from heterozygosity to homozygosity, and then this subpopulation of finches broke away. It was a breakaway population. They've become genetically distinct enough to be considered a new species, and that was observed in real time. So 3 to 4 species a year to account for the 11,000 species in 4,500 years is not a huge stretch, since predictions are coming true on it. Take your time.
What about the sphenodon, of which there are only 2 surviving species? So there's 2 species today. How many speciation rates? What's the speciation rate of them?
Well, so are you gonna, is the bird, but before I answer that, is the bird species prediction, is that consistent? Because it sounds like you just want to jump to another.
In order for your conclusion to be valid, every single kind, as you want to call them, has to be consistent with that model.
Right. Okay, so we'd have to look at the amount of species. So you're saying there's 2 of these species?
Yes.
Well, we have dead ends of branches all the time. Just because some new species pops up like a chihuahua and then will die out, and that's incorporated as well. It's just there's going to be dead ends to branches all the time, but we're just talking about the overall speciation rate.
The overall speciation rate.
Yeah, like
so of everything.
That wolves are speciating at a pretty constant rate, and then we take that back. That's what we would go by, because wolves are the heirloom variety. We don't want to count dogs because they're like sheep. They're the domesticated form, and we're putting them in homes and we're breeding with them. So it's a little bit different. I like the wolves.
Are you taking extinction rate into account when you're coming up with these?
No, because of the mere fact that most of the extinction is more happening recently with deforestation and how much we're messing up the environment. But since our model only goes back 4,300 years, there are going to be dead ends to branches, but we're just taking the overall how many exist today, what their speciation rate number is, and then going back to about the flood time
without knowing the extinction rate.
Right.
So you don't know the extinction rate, so you're just going to assume that they didn't happen.
Oh no, because the numbers still line up with what we're saying. So yeah.
How do you know that if you don't know the extinction rate?
No, there'll be definitely some dead ends and extinctions, but I mean, overall, it's not going to really equate, because that's why we see a little less snakes than there should be, right? Because remember, in our speciation model, if there's 1.2 a year, that means there should be about 5,220 snake species.
But you just said everything lines up.
Right.
And now you're saying that there's less than you'd expect to find. And yet you still haven't given me an approximate number of the extinction rate. There's a lot of vagueness around what you're saying.
Yeah, but you see that the vagueness is there because the numbers are so trivial. We're only losing a couple thousand snakes.
The numbers are your whole argument. How can numbers be trivial when your entire argument is this times this equals this?
Because the numbers are, again, they're very trivial. They're very small. The mistakes are just a little bit, as where the numbers for evolution are huge. They're hundreds of thousands difference, as where ours are a few thousand at most.
Your whole argument is we look at the number of life today and we times that by this speciation rate, which we don't have any historical evidence for. We just go on today's rate, equals number close to, I imagine you say completely accurate to the date of Noah's flood. Your whole argument rests on numbers, and yet you're leaving numbers out.
Correct. Well, again, how about birds? They've tested birds, right? They found that it's 3.3 new species of bird per year in Google, and type up how many bird species there are.
Do you think that number was consistent for 4,000 years?
Yeah, it's the numbers are right in line. But if evolution was true,
what do you mean by in line?
The numbers should be around 15,000 bird species around the world today, somewhere around that from the Ark, right? If Noah brought some birds on.
And how many are there?
Did, because he released a dove, so we know that birds were on the Ark. So if evolution was true and it was splits between dinosaurs, there should be hundreds of thousands of species. Hundreds of thousands.
So how many birds are there alive today? You said 11,000.
Google says around 10,000 species if you pull
So
it up.
you said you predict from, again, that word predict, from Noah's flood, there'll be 15,000.
Correct.
So it doesn't match up.
No, it's a little bit higher, actually. But I bet you they'll find more.
It's 2/3. That's a significant amount.
Well, Google says 10,000. You can assume maybe there's some that haven't been discussed. I mean, you could say roughly 11 or 12,000. It does line up to, and Matt's question has to do with if birds evolved from dinosaurs millions and millions of years ago, and yet all we see is between 10 and we can put a higher number on and say between 10 and 15,000, which is more consistent with young Earth creation, speciation predictions. How do you explain that? How do you explain that, Adam?
I don't want you to go past the fact that you start an argument saying that we expected this number of birds and that's how many birds we have. Now you're saying, oh, we expected this, but they only have 2/3 of that. It's being very vague here. And what I said earlier, it has to be consistent for everything. Well, absolutely everything. And you still haven't given me extinction rate. So when I brought up the sphenodon, which only has 2 surviving species, does that mean there's only been a speciation rate of 1 every 2,000 years?
I'm not sure on those snakes. Sorry.
It's not a snake.
What? Oh, what is it?
It's the tuatara.
Tuatara. Damn. Those are specific. When I was looking for the speciation rates, I went to the general overboard, like all snakes, all bats, all lizards, all birds. And because Noah brought more than one variety of bird, obviously he didn't bring the hawk and it speciated to all different things. He brought multiple. It says the hawk, the raven, the dove. There's multiple different varieties of birds that were on that ark. So that's why the numbers, I think, are going to be higher than the 10,000, what Google's talking about. I think they'll find a lot more.
But you said that the maths agrees with you. And then when I push you on what the extinction rate is, you say you just don't know. If you want to operate in the field of maths, then you need to know the numbers.
I'll add that for you then to my book. How's that? I'll find out the extinction rates.
Okay. Okay. When you've done that, I'd like to see it.
Okay.
So essentially, what we've found out here is that you've taken a couple of examples. Say, for instance, birds. You said we have this number of birds, and we'd expect that because we believe that he had hawks and doves on the ark, which you haven't given evidence for why he brought specific ones on. I mean, he says the dove, but didn't say anything about a hawk, as far as I'm concerned. Eliminated the need for an extinction number, which can vary. You've eliminated the possibility of variety throughout. You've said we have this mutation rate now, but that it doesn't exist in the past 4,000 years. There's all sorts of number factors here that you're missing.
Well, I didn't catch that last part. You said the speciation rates.
You said to me that you assumed that the 1.2 speciation rate was consistent for 4,000 years.
Right. That was on the snakes. Correct. That was just what I could find.
Oh, yeah, snakes, yeah. 1.2 snakes, yeah.
Yeah, I was trying to just find overall snakes. I wasn't just trying to find a species-specific one. I would like to know, like bats, for example. Bats are categorically much easier for people to find because their iguana was worth money. So they want to find out, well, how fast do these species grow? What's the most amount of money we can find? So they found 1,240 species exist. And speciation rates seem to be like 3 to 5 years on average. Well, we extrapolate.
Do you agree that speciation is dependent on the environment?
Yes.
And if the environment changes quite a lot, then you'd expect the speciation rate to change.
Yeah, sure.
So in the space of 4,000 years, would there have been enough environmental changes to drastically change the number of speciation events?
Oh, it drastically changed the human. Well, remember, before the flood, we believe that the environment was different. So speciation rates number were higher.
Yeah, we're talking after the supposed Noah's flood.
Right, exactly. So it was more consistent after. That's why everything dropped down dramatically and life extension, and then all of it kind of plateaued and remains the same. Like humans always tend to live, or should, around the same age, unless there's a mistake or some disease. Humans should be living around the same, but before that, it was much easier.
So taking bird examples, you'd expect the speciation rate of birds to change over 4,000 years.
I mean, not much, really. Just the same, really, as humans. I would imagine that the more species there are, the more they diversify, and then the more species they would get from them. obviously because the numbers are going to be growing. Yeah.
Okay, so an overview of what we've discussed. The birds, 15,000 species is what you'd expect. We have 10,000. You admit that speciation rate can change. You don't give an extinction rate. I don't understand how this is an argument for you. There are so many missing pieces to this puzzle.
Okay,
I don't understand how you can bring it forward.
Let's take, for example, then that this extinction level is quite high. We can erase the 5,000 and we're back down to actually 10, what the actual number that we do see is. I extrapolated 15,000 because I thought there would be a lot more based on there's being more bird kinds in the ark. So that's why
you haven't established how many kinds there are for a start. Again,
right.
That's another number we're missing. How many kinds are on the ark?
Right. It's okay. That's when we get into the DNA barcoding for the birds. We're going to have to find out exactly how many birds were on the ark, and that'll be good because now we can differentiate. We're going to be able to see that the hawk is a different kind of a bird than a dove, and the dove is a different kind of bird to a crow and a raven. They were mentioned throughout. I think Job mentions the hawk and the raven. It says that in Genesis it mentions the dove, because obviously it was released by Noah. So we get it, but they weren't specific. They didn't say we brought this many on the ark. I wish they would have. It would have made our job today a lot easier. But I didn't know that they probably didn't know we'd be getting questioned like this. So.
Yeah, the whole again it comes back to DNA barcoding, and that's another impasse.
Well, how about in vitro fertilization? If you could take a lizard and fertilize it with a snake, that would show us that they are the same kind. But that doesn't really happen. Same thing what happens with chimps and humans. I mean, there's a guy named Ilya Izonoviev or something in Russia. He was a Soviet biologist, and he was a world famous for artificial insemination. And in 1910, he was given permission by the World Congress Zoologists that said you can make a human-ape hybrid. Now, he's world famous. He was the first person to create a horse-zebra hybrid. I think it was called a Zorses, and he can do anything with them. He said, if anybody on Earth exists that can make this thing, it's me. So they wanted to create a new a super soldier that was a mix between an ape and a man that they could give a gun and go kill people. So he did this for years. As a matter of fact, he took 3 female chimpanzees and artificially inseminated them with human sperm, bypassing their outer egg and directly into the zygote. He failed on every experiment he did, because they're not the same.
Are you saying then that you mentioned in vitro fertilization? Are you saying that kinds are creatures that can't reproduce with each other?
Yeah, that would be the separation. Yeah, exactly. That's one.
So that defines kinds for you, the lack of ability to reproduce.
One of them, yes. Yeah, ours is.
Do you agree then with Standing's previous definition, which was descent from the same gene pool?
Right. Well, that's what I mean. If the same gene pool would be for a snake and a lizard, then they would be able to in vitro be fertilized, and we would have to now say, okay, they are related, and now we have to.
The ability to reproduce is depending on similarity between genomes. We know that genomes diverge as the generations go by, so eventually they will not be able to reproduce. So therefore, there would be different kinds.
I didn't get the question. Sorry.
So you said that it's down to whether they're able to reproduce,
right?
And that is and that coincides with being in the same gene pool. We know that gene pools change over time between generations, between people. So over time, gene pools will diverge. So eventually, they won't be able to reproduce anymore. So there's a contradiction in your because they'd be from the same gene pool, but they wouldn't be able to reproduce anymore.
For example, all humans are able to reproduce because it's mankind. It's the overall. If we were related to apes, which are in the same species according to evolution, then we should be able to in vitro force a hybrid out of the two. Same thing with what we do with donkeys. We can hybridize something out of them. We can cross all horses because all horses are related. But if dogs and seals were related, then we should be able to cross them to some degree and get some kind of an offspring. We can hybridize them. We could in vitro. We can pass up the form of the egg that might make it impossible under normal circumstances between the two mating. Did you know there's a theory that believes that pigs mated with chimps to create humans? That's the newest theory in evolution right now.
I have not heard of that,
Yeah.
and I don't even think I should need to comment on that. That sounds patently ridiculous, and I don't know where you've got that from, and I don't know why that's been stapled to evolutionary biology. I've never heard of it. I've never seen it in the literature. I don't know where you've got that from, but genomes change.
If I could make a suggestion, just so we have enough time for a good Q&A, James, could we maybe give Adam a couple minutes to wrap everything up, and then give me and Matt just 2 minutes to wrap everything up and jump into a Q&A?
We usually jump from the open conversation, given that unless you guys had wanted closing statements, we could jump right into the Q&A, because right now the stream, I'm really thankful and surprised we've made it this far, because my connection over here has been really weak. And so thanks so much for everybody listening. Hopefully at least the audio has made it through. I think it's frozen a bit on the video, but it sounds like generally the audio made it through, which is great. I want to say thanks so much for being here to our guests. The debaters, the guests, are the lifeblood of the channel, so we can't thank them enough, as it's just a joy to get to listen to them. Thanks so much, guys, for being here.
Awesome, guys. We're here this afternoon with Adam Heap, Raw Matt, and myself, of course. We are continuing the discussion with Adam Heap. So I want to thank him for joining us this evening. If you haven't seen our first talk, more of a formal debate on modern day debate on generally the same topic of ancestry, universal common ancestry, or I guess you could call it biblical limited ancestry. I definitely recommend checking that out. This is going to be more of an informal dialogue, touching on maybe some of the loose ends or some of the topics from the first dialogue that we'd want to elaborate on more. Adam always makes for a good discussion. He's, from my understanding,
That's a lie, by the way.
Hey, you paid me to say that. Now
You can't prove that. Prove me the scientific study that says that I have a good discussion. I can't find any.
All right, I'll accept correction on that one. From my understanding, Adam's got a background in zoology. I think he's also has a background in herpetology. Actually, did you want to clarify that, Adam? Or
I have a master's degree in zoology and herpetology. Herpetology being primarily the study of reptiles and amphibians, but I amphibians are I'm more into the reptile side, me.
the cool side.
Yeah, the cool side, yeah.
Well, that being said, we always enjoy talking with Adam because he's certainly qualified and well educated, and he's looked over a lot of the material that Raw, Matt, and myself have put out. So he brings forth good arguments and good objections, which gets us all to think. And like I said before, it leads to a good, memorable discussion. So once again, thanks guys for joining us. I'll pass it off to Adam Heap and Raw Matt as well, if you guys want to say a couple short introductions, and then we'll jump right into a couple related topics to ancestry.
I'm happy to have my introduction as a simple yet tangential question, and that is, why is so much as community Canadian?
Oh, are you saying because your intro is going to lead in with the question? Do you want Matt?
No, that's just it. I don't have an intro, so that my intro is just a tangential question that I've always wondered. Why are there so many Canadians in this bloody community? Where do they all come from?
Where did we all come from? Canadians?
Yeah.
Canadians produce Canadians, my friend.
But at one point they weren't Canadians.
No, that's true. We could probably trace. I could probably trace my Canadianness, I guess you can call it, right back to Adam and Eve. Maybe. What do you think, Matt?
They were Canadian.
Well, you're American, Matt.
Yeah, but Canada's above us and they're bigger, so I'll leave them alone.
Oh, you know what? I was looking on the map yesterday. I was doing some work in my brother's house. He's getting his floors done, and he's got this big picture of the map. It's not flat, sorry guys, but
okay.
I was looking at the country sizes, and sometimes when you glance at it, if it's been a while, I mean, the size of Russia or the size of like Canada too, even in comparison to like the States. Or so, Matt, don't mess, brother.
That's true, but I think all those maps are fake news. So
I heard the other day that the last place on Earth to ever be discovered was actually Antarctica. Which is probably quite hard to believe, considering the tiniest little islands that you get in the Atlantic and Pacific Oceans that were found before the whole of Antarctica.
Yeah, that is interesting, actually. Well, Adam, you're always welcome to come visit in Canada. We've got really good coffee. You know, we're pretty easygoing to talk to.
You've got to provide me a source for all this, by the way.
Okay, so I guess getting into it then, did you, just to start it off, if we're going into Ancestry, and if not, you know, not putting you on the spot, but we discussed mitochondrial Eve a great deal in the first discussion, as well as Y chromosome Adam. Mm-hmm. You did bring up a very interesting study done in Chinese men, I believe it was. Yeah. Do you want to elaborate on that, actually, just to kind of get the audience up to date?
From what I recall from that paper, it was essentially 2 Chinese men, 13 generations apart, and they measured the amount of differences in the mitochondrial DNA. So essentially, they added it all up. They saw where the common ancestor between the two was, which was about 1805, and it was a case of simple multiplication, essentially.
Was this the Y?
That's the Y chromosome. Yeah.
Right. Okay. Just clarifying.
Yeah. So that's it. From that, they got a mutation rate, which aligned with the human chimp split of between 5 and 9 million years.
Right. So I think in that portion we were going over how we can look at like mitochondrial DNA, for example, and I know there's been several papers looking at that, you know, mutation rate and coming up with a date for E, for example. We were pointing out the fact that, I mean, not only does the mitochondrial DNA go back to 3 major groupings, which we can get into later, that we would say are the 3 daughters-in-law of Noah, but the mitochondrial DNA itself, you know, goes back just 6,000 years to, you know, a one single female ancestor. But with the Y chromosome, you're saying based on this study, even though the Y chromosomes in the world today, like when we actually focus, let's say, on the variation of it, the Y chromosomes have very little variation, right? But based on that Chinese study and based on the mutation rates in that study, it takes the Y chromosomal ancestor back like 200,000 years, as expected by the evolution model, right?
Yeah. Can I just apologize for my coughing, by the way? Just some coughing.
No problem.
So, were you continuing your point there, or?
No. I was just clarifying your point that given the empirical method on mitochondrial DNA and given the empirical method on the Y chromosome DNA, you're saying there's a contradiction there.
Yeah, so I'm saying if you're gonna say that the mutation rate in the mitochondrial DNA, simple multiplication, constant rate brings us back to roughly 6,000 years. Then I don't see what your problem is when we do exactly the same process with Y chromosome, which brings us back several hundred thousand years.
And then, because I typically say that we look at the entire genetic structure as a whole, which speaks to us about the literal Adam and Eve, and you rightfully point to the Y chromosome variation and the mutation rate as expounded upon in that specific paper. Like, I know there was 2 initial papers. One I think that it's in 2009 is the one you're referring to with the Chinese men. Is that right?
I think 2009. Yeah, I think it's that year.
And then they did another one in 2015. actually, before I cover those papers, so in our first discussion, I pointed you to a paper. I can send it to you again after this.
Yeah, sure.
I think I sent it in the comment section, so that could be the miscommunication. But Dr. Nathaniel Jensen, he looked at the Y chromosome, and he looked at all these. I think it's four or five papers that are out on the Y chromosome, and he concluded empirically that we only observe 4,500 years of mutation accumulation in the parental ancestry contained in that record of the human Y chromosome. Did you actually have you read any of the? Is it just the 2009 paper you read, Adam, or was it all of them?
I think it was 2009. Can I ask the point you're talking about now? Is it the one? Because I've read parts of your 100+ falsifications book. Is it that one that's covered in one of the first few bits?
I don't think so, because the Nathaniel Jensen Y chromosome paper was just recent. I'm not sure if we've added it to the book. Matt, can you clarify that?
I did, but it's not the first one. The first one focuses on mtDNA rates, and then the Y chromosome rates are much later.
That's something I wanted to bring up at some point.
Yeah, we can do that. So I would just say, to break it down for the audience too, when it comes to the Y chromosome, all we do in the easiest way is we just take father and son, and then we count how many mistakes occur each generation. This is the empirical method, right? Mistakes happen every generation. The question is, how many? Is it every generation? Is it every few generations? We don't really know until we get say dad's Y chromosome, son's Y chromosome, grandfather's Y chromosome, and do an analyses, and then measure the rate of mistakes. So as Adam pointed out, they did an initial study in 2009 with the Chinese med, and another one in 2015. And Dr. Jensen covers this in his most recent paper. Now, those first two studies, they were based on low quality data and low quality DNA sequencing. So the results that were concluded are what Adam described. He's right on that the rate of mutations that were discovered were slow, which met the expectations of the 200,000 years for the evolutionary Y chromosomal atom. But the important thing is that they did two additional studies, one in 2015 and another in 2017. Those ones, though, those were based on high quality DNA. And what they discovered, which is fascinating, actually, I recommend reading the paper. There's a ton of good sources in it too. They discovered that in the supplemental material, so you're gonna have to look at the details of this paper, but that the number of father to son Y chromosome differences was actually approximately 10-fold higher than previously discovered and expected from the first two papers. So, and they readily admit this as well in the paper, and they even admit that those empirical findings urge them to explore additional filters. I've got the quote here from the paper too. So in other words, they took their high quality DNA results and filtered stuff out that doesn't fit their evolutionary timescale. But the point is those subsequent studies, Adam, that was based on high quality DNA sequencing on the Y chromosome, demonstrates a Y chromosome atom consistent with Young Earth creation.
How are you distinguishing high quality from low quality DNA?
In the study, Dr. Jensen, well, I mean, these studies where they look at the high quality DNA in like the actual secular sources, they explain their methodology. They explain, I guess, the high quality DNA versus the low quality DNA from the initial study in 2009 and 2015. They readily admit that it is, there is a difference in those findings. So I'm not exactly sure.
Yeah, what I mean is, are you saying that if something's considered low quality DNA, does that mean that mutation rate is different?
It may.
What does it mean regarding mutation rates, basically?
So if it's lower quality DNA, then the mutation rate derived from it could be off. That's why it is good to look at if if your first study, let's say on the Y chromosome in 2009, all they had was a low quality DNA, that's really the best that they're going to have at that point in time. But as time goes on, if you get additional studies where now they've got higher quality DNA and all of a sudden they can look at it better than the low quality DNA, I mean, that's kind of just a fact of science, right?
What you're saying is that low quality DNA somehow has different mutation rates to high quality DNA, or less consistent mutation rates from high quality DNA? Because the whole point of this is that we're just measuring mutation rates. So what difference does it make if it's supposedly high quality or low quality?
Well, the low quality DNA that was looked at in 2009 can come up with inconsistent results. So yeah, you're right. They just take, father and son, and then they count how many mistakes occur each generation. Every time there's a mistake, there's a new branch in the family tree. Take those branches back to one male ancestor. How long ago is the question? Well, the low quality DNA sequencing had inconsistent results that were consistent with the 200,000 years for Adam that you're talking about. But in the subsequent studies, the high quality DNA demonstrated that this Y chromosome Adam lived just actually 4,500 years ago, Dr. Jensen proves. And they admit this in the paper, like their exact quote here in the paper, and I believe you'll have to find it in the supplemental material. They say the number of father to son Y chromosome differences was approximately 10-fold higher than the expected number. Considering the range of published Y chromosome copying mistake rates, this finding prompted us to explore additional filters. So they did explore, additional filters in explaining the data, but Dr. Jensen just took that observed mutation rate in the Y chromosome based on the empirical method, and he discovered that this Y chromosome ancestor only lived about 4,500 years ago, which would actually be our nearest Y chromosome ancestor, which would be Y chromosome Noah.
I'm not familiar with any study that says 4,500 years. The minimum date, the minimum time backwards that Y chromosome is supposed to have dated is about 60,000 years, and that's the lowest estimate. We're going to have to move on from this because I don't
want to stick on one topic.
I'm finished. I don't think we're going to get through to the difference between low quality and high quality, because I'm assuming that you think that the low quality and high quality must have both been there from the beginning. So surely it doesn't matter if they're high, low quality mutation rates. But from what you say, should be consistent.
I would just say the high quality DNA gives a better and more consistent mutation rate. And it is also consistent with creationist predictions and actually evolutionist expectations on the decay of the Y chromosome. I know Matt touched on that in our first dialogue. Matt, did you want to jump in here and touch on that? So the Y chromosome is degrading and accumulating mutations at a rate higher than, for example, I think even the mitochondrial DNA. Like it is literally tenfold, as they say, tenfold higher than expected. Matt, did you want to touch on that?
Sure, yeah, but for Adam here, I pulled up the study, and here's how they discovered it. Basically, what it is they said that they filtered variant sites and found that a complete genomic study only kept the allelic SNPs and VQ high. I don't know what that stands for, but it basically has to pass a score to be 95% or better. So the Y chromosome that they had before was of lower quality, meaning what they say in the study is the human Y chromosome is known to have large segments of sequences that are difficult to map until now. So basically, they had a smaller segments of the Y chromosome, not a complete genomic. Now they have 95% or more of the Y chromosome, and it's high quality, so they can get a more accurate study, our trio study. They can see it better. So that's why they got a faster mutation rate. Jensen's the one that mapped it out and found 4,500 years.
Now, actually, real quick, Adam, before you talk, so is it as easy as the high quality DNA that was discovered or used is just a higher range of testing, a higher range of samples to compare versus the low quality DNA, Matt?
Oh, you were asking me. I thought you were asking Adam something.
Well, I'm just trying to break it down for the audience in a more easier way to understand. In a layman way of understanding, is that what it is? There's just a better range of testing and comparisons on the Y chromosome DNA in the higher quality
Right,
version?
exactly. They tested not just more people. They kept testing the Y chromosome database and kept compiling more segments until they had a more complete Y chromosome.
Right.
Yeah.
It was just like adding on to the original.
Exactly.
So how much, when Nathaniel Jeanson did this study, how much of the mitochondrial genome was tested?
I think this one wasn't the mitochondria at all. I think it was just the Y chromosome.
Oh, the Y. Sorry, Y. That's what I mean. Right, Y chromosome.
Yeah, that's all he was looking at for the study. I posted a video on our channel of it. Unfortunately, it was kind of vague. He said it is in his book, though. So I can get you the specifics on that after. I didn't research it out.
Okay.
Yeah, if we want, we can just move on. Yeah, I just wanted to show that, like in the mitochondrial DNA and how the empirical method, determines that this mitochondrial ancestor lived just 6,500 years ago or so, and that she would be the one female ancestor of all people. And I don't want to strawman the evolutionists. I know that they believe that Eve and Adam were part of a population, but that's a separate argument, possibly for a separate day to not bog down the debate.
I was going to ask. The general consensus is that even if it was dated to 6,000 years, that doesn't mean that should be the first. Should be part of a population.
Yeah, and that's what I was going to say. I mean, we could discuss that now. The thing is, the out of Africa scenario involving the population bottleneck has some really, really significant problems with it. I mean, it was actually the low genetic diversity that was discovered in the human genome, right? We're all 99.9% similar. That's incredibly low. So and you probably know this, they invented the hypothetical out of Africa population bottleneck to explain the low genetic homogeneity, right? They had to reduce the population. But the thing is, that population bottleneck, Adam, and you can comment on this as well, it would have been at a near extinction level. It would have occurred for a prolonged period of time, and it would have resulted in a severe loss of genetic diversity corresponding to the fixation of bad mutations and severe inbreeding depression. That's the problem. So this inbreeding would have occurred for not one generation, not two generations, but thousands of generations. So that so-called hypothetical population bottleneck of 2 or 10,000 people would have been so genetically compromised that my question to you, Adam, regarding it is, how could such a small, nearly extinct, as I said, genetically compromised population such as that suddenly explode into all parts of the planet, seizing dominion over the world in order to make Adam and Y chromosome Adam coming from a population even feasible?
I'm not familiar with the studies on it nor any of the science behind it. So if I were to give you any answer, it would be purely off the top of my head. Is the question essentially, how do we get from such a low number to the amount of people we have today? Is that what you're asking? Yeah,
well, I'm pretty much saying that out of Africa population bottleneck would have been so severely genetically damaged based on the accumulation of mutations from inbreeding, right? Those mutations, those recessive mutations, would have come to the forefront. We can see how implausible that is just by looking at the cheetahs of the world today. We know that they're down to like 6,000 or 7,000 due to prolonged inbreeding. So it's gone on for so many generations that there's been so many bad mutations that have been fixated. So their sperm is degenerate. Conservationists are incredibly worried about the cheetah, and we're not going to see the cheetah suddenly explode into all parts of the world, seizing dominion over the planet. But that's what they say occurred in this out of Africa scenario. So I understand that that's the hypothesis. I'm just saying that there's a lot of problems associated with it.
Yeah. So you're saying there's a problem with, say, if the population was down to 10,000, that would cause severe problems. How then do you explain everybody coming from, firstly, 2 people 6,000 years ago, and then 4,500 roughly years ago coming from essentially one bloke Essentially one, because you can remove the first one. The bottleneck is the latest.
Oh yeah, I'm just saying that there's bottlenecks involved in your out of Africa scenario, and then also our scenario. The thing is with our bottleneck, so you got the bottleneck at creation of 2, and then you've got the bottleneck at the flood of 8, I believe it is, and then the Tower of Babel. So 3 essentially, bottlenecks. The thing is, all of them were not prolonged; they were just one generation, and each bottleneck was followed by exponential population growth. And also we explain the vast majority of DNA differences as pre-existing functional DNA differences, as compared to the evolutionist that explains the vast majority, if not all, the DNA differences as a result of mutation over time. So the first bottleneck
I booked in there. It doesn't matter what was originally put into, because essentially you have alleles, and if you've only got 4 people, then you've got 4 different alleles. That's the entirety of variation. So you say that there's this created massive amount of variation, but if you've only got 4 people, then you've only got 4 alleles, potentially.
Right. So actually, that is a good question. I'm kind of glad that you brought that up. So that argument technically comes down to the question, how do we define an allele? So if an allele is defined in terms of a gene unit, then yeah, you're right. Then generating allelic diversity by saying, mutating one gene per event, mutational event, that would produce almost no diversity. But the thing is, an allele should be defined as a single genomic position. Okay, Adam? And that means that allele is independent of its relationship to a gene. So that means enormous allelic diversity can be generated not only by mutation, but also by genetic processes such as recombination and gene conversion, for example. Let me break it down for you. Okay,
yeah, so that's how evolution happens.
Right. But evolution has to explain. Well, here I just want to break this down real quick, even for the audience, because a lot of that's technical. A single gene. Okay, so it typically spans thousands of nucleotides, and single nucleotide variants might be distributed throughout that gene, okay? Let's say, for example, maybe at 90 of the nucleotides within the gene. So if we take the genomic position definition of allele, then let's use the animals at the flood and the ark. Every single one of those single nucleotide variants could have existed in a heterozygous state in each of the individuals of the pairs brought on board the ark. And then at creation, we know that God created and evolved. But I guess going back to the out of Africa and then our bottleneck, yeah. So ours is one generation, no accumulated mutations. So there's no inbreeding problem, because inbreeding involves the exposing or the coming to the forefront of the hidden reservoir of genetic mistakes. But if there is no genetic mistakes, as our model would suggest, then there wouldn't be any inbreeding or genetic bottleneck problem. But for you, like, how would you explain it? If you have all these mutations coming to the forefront for not just one generation, not 2 generations, but thousands of generations, how did this incredibly genetically compromised population of 2 or 10,000 leave Africa, explode into all parts of the world, and then seize dominion over the planet? Like, is there any feasible way of that occurring?
I don't know. I haven't looked at the papers.
Yeah, no, and that's fine.
I'd like to refer you to someone who's actually looked at that stuff, because I haven't looked at it.
I wasn't planning on. I've had like full debates on that exact topic. I'm fascinated with the out of Africa story. We can just. I was just answering. I don't like to straw man the evolutionists. I know that they say that the Y chromosome Adam and the mitochondrial Eve, were part of a population. But I'm just saying that idea is not really supported by the scientific evidence, because you'd have to explain how that would even be remotely feasible. Plus, if these 2 ancestors, as showing here, based on Y chromosome and mitochondrial mutation rates and variation, lived just 6,500 years ago, then we should have plenty of evidence, even in written records, of some kind of out of Africa type scenario. But I know you had a question as well about the Y chromosome in the book that you wanted to direct at Matt, or because I want to give you some.
I don't want to move on too far from what we're talking, because I do want to say that you're saying that my problem is that I had a genetic bottleneck of around 10,000 people. But you seem to shrug off the idea that you've got a bottleneck of essentially 4 people, because you've got Noah and his sons who are all derived from him, so he's the bottleneck. So Noah and 3 women. So you're saying I've got a problem with 10,000 people so many thousands of years ago, but you haven't got a problem in less time with much less people. So if you're going to give me these problems, you've got to take the problems as well. And when we talk about genetic bottlenecks, it's not just about mutations, it's also about immunity to parasites and bacteria. Because if there's only so many people, then what if a virus comes along and infects? If they've all got very similar genes, then they're screwed, essentially. And if we're going to look at this realistically, if you've got 4 people, then you've got a maximum of 4 varieties of each allele. I mean, I know you've talked very vague terms about heterozygosity when it comes. You lost me a bit with that, but do genes come about via mutation? Do we get new varieties of genes?
Well, I'm just saying that, so to go back to the allele, I'm just saying if you define an allele as a single genomic position independent of its relationship to a gene, which is the way it should be defined, then I'm just saying producing variety according to our created heterozygosity hypothesis wouldn't be a problem. And also when it comes to like the genetic bottlenecks, well, real quick, I just want to address your points. I'm trying to remember what you said. So with the viruses, for one, viruses are beneficial. I mean, you have trillions and trillions and trillions of viruses in and on your body, Adam. You actually have more viruses than you do bacteria and cells, and they're all beneficial. They help regulate the number of species of bacteria in and on your body. In the environment and ecosystems, viruses help regulate bacteria, for example, in the ocean as well. Endogenous retroviruses, we know, are highly functional. So mutation and genetic entropy over time, this all comes back to the genetic entropy model. Adam, because if we started with no mutations at creation with Adam and Eve, and we started with genomes that were front loaded with genetic diversity, there's not going to be any inbreeding problems, not only for that reason, but as I explained, the population bottlenecks were only one generation, okay, one generation at creation, one generation at the flood, and they both were followed by rapid and exponential population growth. So for one, very little of that original created genetic diversity would be lost because the bottlenecks were only one generation each. But the problem with your model is all those DNA differences anyways you explain as mutation, okay? And yeah, like recombination and gene conversion can produce new chromosomal combinations. That's true. I wouldn't say any new genes, but new combinations, new traits can come about through this process. But if our DNA differences are already built in, they're created functional DNA differences, that means new varieties can be created rapidly. Every single generation, especially in creation, in the pre-flood world. I mean, speciation events would have been far faster and more frequent than today. So I think it just goes back to the created heterozygosity hypothesis and genetic entropy that we've talked about that before. We're accumulating 100 new mutations per person per generation. Take that accumulating mutation problem, Adam, back to a point of least accumulated mutations. That would be a point of creation, a point of no genetic degeneration, no genetic mistakes, therefore no inbreeding problems in that first generation creation related bottleneck. Take your time. I know I talked a lot there.
You start to go into genetic entropy there, which I think I talked about in the last one as being a very obscure scientific idea that's only put about in places like Answers in Genesis and this Nathaniel Jeanson, who you quote quite a lot. I've looked at the literature and there's nothing about genetic entropy. And it's one of those things, as well as a lot of other things like mutation rates. It's not just about some specific examples, like you say there's genetic degradation in humans. It has to be across the board. Absolutely everything needs to line up with this. And that's not what we see.
Well, the thing is they found that mitochondria and different things does have different rates. For example, in reptiles and birds, it's extremely fast, and it's slower in others. They haven't actually determined a universal clock. They found that some things have faster clocks because they have faster and shorter lifespans, or some will have a faster clock because their metabolism is extremely fast. They haven't exactly figured out the total correlation yet, but Standing for Truth was going crazy with the science. I just would say that here's a logical question. If you just do the math, evolution says that a bottleneck that happened 200,000 years ago, there were supposedly between 5 and 15,000 women. So if you cut that in average, that's 10,000 different people, or 30,000 individuals. Now, let's say that if those half were women, again, 10,000, that's the average, but yet we only have one today, right? One line of mtDNA. That means that 9,999 women either had to die or birth to girls for that to happen. So it seems kind of improportionate, considering evolution said, no, there were plenty of other women. There were thousands.
Sorry for my cough. You do not think that they could be part of a population then?
Well, the population,
all the descendants of, say, one person could end up dominating the entire population, or at least all of the members of the population that we've tested.
Okay, here, I'm going to try and break it down real quick, and then Matt, I don't want to jump in on your time, but okay, so it's as easy as this. So over deep time, as evolution would have us believe, is how we got all the species, all the change, of course, all the evolution. Any large population will accumulate massive numbers of mutations, okay? That is how the evolutionists explain the genetic diversity in not only humans, but animal species, for example. Now, this becomes a very serious problem, Adam, for evolutionary theory, because we now know, as I indicated earlier, that the human species has very little genetic diversity, okay? So that observed low genetic diversity is not a problem for us, because we expect that based on the biblical perspective. We came from just two people. God created Adam and Eve. What would we expect? Low genetic diversity, and that's what we see. Now, this was a huge problem for evolution, from the evolution perspective, Adam, because of the low genetic diversity. If we've been accumulating all these numbers of mutations for millions of years, in, obviously there was variable degrees of populations, we shouldn't have this low genetic diversity. So they came up with the hypothetical out of Africa population bottleneck. I think they say maybe around 70,000 years ago, which was a near extinction event. So those mutations that have been accumulating over time, okay, they've now come to the forefront. Those enormous numbers of deleterious mutations have gone to fixation. Now, it's not one generation like our population bottlenecks, followed by rapid exponential growth. No, this actually occurred for many generations. That's the only way that they can explain the reduction in homogeneity. But by the time that population suddenly exploded out of Africa into all parts of the world, they would have been so severely genetically damaged that there's no feasible way. I get that it's a hypothesis. I'm just saying there's no feasible way that could have taken place. Just look at the cheetahs today. They're down to 6,000 because of their population bottleneck. Their sperm's degenerate. Conservationists are worried that they're going to go extinct. That's what happens in small bottleneck populations. So that's what we're saying. Yeah, that hypothetical population associated with Eve and Y chromosome Adam has some really, really, really theoretical issues that I haven't seen anybody deal with.
There's just a few points. Again, you've just bypassed the fact that your bottleneck is in a much worse position than mine, and your excuses are, as far as I'm concerned, baseless and nonsense. And not only if you take one example, humans, I'm not sure on the number that was around in this supposed bottleneck. I haven't looked at any of those studies, so I can't really comment on that. But it's not just a one species thing. You've got to show trends. If you think that everything should have descended from creatures 4,500 years ago, everything needs to align with that. It's no good giving me a specific species that could have gone for a bottleneck roughly around that time. You've got to show a trend. It's got to be a universal thing.
Well, you have to remember that it is a universal thing because, for example, as we say, God created two people, okay? So Adam and Eve. That means that Adam and Eve would have had differences, DNA differences within themselves, And then, of course, this
How do you know
idea.
that? How do you know that?
Well, I'm saying this is our hypothesis, and testable predictions flow from it. That's when we can get in, because if God front-loaded Adam and Eve and all the kinds with these front-loaded functional DNA differences, our prediction would be, okay, the more we sequence the genome, the more we look and study these DNA differences, we predict that the vast majority of these DNA differences, DNA elements, right, for example, the jumping genes, the ERVs, the ALUs, the pseudogenes, these would all play a functional role in the species. But I'm just saying that that's the testable prediction that flows from it. But real quick, I wanted to answer your question of universally. Well, the fact that God encoded Adam and Eve with these front-loaded functional DNA differences applies universally among species, okay? So, for example, each created kind, Adam, was front-loaded with functional DNA differences that, as I've said before, through a variety of processes and mechanisms, such as, let's say, gene conversion, recombination, genetic drift, isolation, migration, whatever, those DNA differences combined with those processes has led to the origin of species. Now, what do we see? Okay, so the Bible says God created animals in bulk. He didn't just create two like he did with Adam and Eve. So we should expect a higher genetic diversity in the animal kinds, in the animals seen around the world. And that's exactly what we see. And then in humans, we see low genetic diversity consistent with that hypothesis. Take your time.
But every animal, well, at least every land-dwelling animal was restricted to either 2 or 7.
Right.
For Noah's. So you're expecting everything, even less genetic diversity in everything that isn't human. So you'd expect surely smaller levels of diversity within animals, but we see animals with incredible levels of diversity. I mean, just look at, we talked about cobras, and I hate to always bring up snakes, but their diversity is enormous just in cobras.
Yes, I agree. So here's the thing, though. Okay, all of this to say that the evidence does correlate with, and I understand your objection with the bottleneck of these kinds, and I'll explain that problem too, or an answer to that problem. But this is all to say that the evidence does indicate that God created animals with a greater ability to diversify. In other words, the original animal kinds were front-loaded with more diversity than humans. And this makes sense since we know, as I said, God created populations of animal kinds and then only 2 humans, Adam and Eve. This is why we know the human race has low genetic diversity, which would suggest that we came from a small population. But not only that, like we talked about earlier, which is why it's so important, when we combine the mitochondrial DNA and the Y chromosome data, it wasn't just a small population, it was a population of just 2, just as the Bible tells us, Adam and Eve. Now, at the bottleneck with the animals, because it was only 1 generation, and this is just basic science too when it comes to bottlenecks, very, very little of that created heterozygosity would have been lost because it was followed by rapid exponential growth. So what we see actually correlates perfectly with this hypothesis. Plus, Matt was explaining in the last debate that study with the DNA barcoding, it proves that over 90% of all life originated at the same time based on the genetic diversity seen in that CO1 gene in the mitochondria. So everything is correlating universally, as you said we should find, and that's exactly what we find.
Can I just nip to the lav? It's my fault for drinking too much cappuccino. I'll be right back.
No problem.
Right, cheers.
Yeah, once you get a scratch in your throat, it's so hard to clear out when you have to talk. It just gets worse.
Actually, that's a good time for an intermission for me too. Matt, I'll let you, I know I've been talking a lot. I don't want to dominate the entire conversation. You take over for a few minutes for when he gets back. I'm going to run for a quick bathroom break too.
All right, me and Praise. What's going on, Praise? We got to entertain the audience. Oh, you're gone, aren't you?
No, I'm not. 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 Good conversation, man. Good conversation. Loving it.
You're gonna think somebody's possessed on this channel. Someone just tuned in.
Matt, sorry. I don't know, because I know with what your question, Adam, before we took our bathroom breaks, I'm glad we're all back. Matt, with that study with the genetic diversity, that would indicate the not the creation event, but the flood event, starting with all those animal kinds based on the diversity, correct?
Exactly. That's what that event is actually showing. That's why there was so little barcoding gap between all life. Everything was very short because they expected evolution to be true. They didn't expect to find any gaps really whatsoever. And the low diversity showed that all life was recent and appeared at the same time.
So you mentioned, am I allowed to get back into it now? Are we already set to go?
Sure. Yeah.
So when you were talking there, you said that there's even more genetic diversity in at least the majority of animals, I suppose you implied, from fewer individuals coming off the ark. And you said it was because it was the one generational thing, they maintain the diversity, but that's not how genetics works. If you're restricted to 2 individual animals, then you've got a maximum of 2 varieties of a gene. The whole population doesn't get put into these 2 creatures. It's restricted to 2 genotypes.
Correct. Think about it like this. We say that things were on a family level. So when Noah went onto the ark, he would have brought, say, a wolf and a fox. And so all the species that we've seen since that time has the ability within those original wolf and fox that went on the ark to diversify into the species that we see today. That's what we say. So birds, yeah, a lot more birds went on the ark. A lot more than horses would have. Probably 1 horse pair, because look at how few there are. And they speciate very.
How do you decide?
That's where we kind of get into trying to define what a kind is. Most of the time, it's always been referred to as just something that can bring forth after its kind. That's more along the line of referring to Noah and what went on the ark. And we're trying to make it go even further back. So we're trying to incorporate DNA barcoding with the zygote fertilization and the orphan genes. We try to look more broad spectrum and see what we can actually look at to place into a particular lineage.
So yeah, I'd love to move on to kinds. I think after we've had the bathroom break, it's a nice place to move the topic onto that. So if we're all happy, we could move on to like the definition of kinds and stuff like that.
Sure.
Yeah?
Yeah, I'm good with whatever you want to do.
So I think a good place to start there is for a definition.
Sure.
I know that you gave me 1 or 2 definitions last time, but just to, make sure there's no confusion going ahead from now, let's have it again.
No problem.
Are you asking for a definition from me or Matt?
Oh, either of you. I'm assuming it's going to be at least roughly the same.
Yeah, I figured since this is his time, he can do it. I mean, the definition I always give is organisms that descend from the same ancestral gene pool, because then it's not solely based on reproduction, because we know how genetics work. There's going to be some species that, based on genetic differences, based on divergence, they may not be able to do or be able to reproduce. There may be physical reasons for that, for example, with a Great Dane and a Chihuahua, but we need to look at the blueprint. We need to look at the genetics. I don't want to take Matt's time there. I just heard some silence, so I wanted to jump in. But Matt, take over, brother. Take your time.
Yeah, no problem. No, I mean, that's a good answer. Anything that descended from the same ancestral gene pool would have the ancestry built in from it. We would be able to look at a human, for example, and say, okay, what makes us different? What makes us stand apart? We say, well, the best way of doing it would be, I really like the DNA barcoding. That's a really good way. But a lot of people don't know about it, so there's no reason to bring it up if you've never understood it. So the best way to explain it would be zygote fertilization, because we know, for example, that a horse and a donkey and a mule are related, but sometimes they can't interbreed, right? But we know that they can in the zygote fertilization. You can do that in a laboratory, and we can see that they're related. Some people have even tried it with chimps and humans. I mean, go back to the 20s and 30s, and it didn't work. So, and these people were...
Yeah, we touched on that last time. Now, the hypothetical I'll give you is that it's basically the same as last time. You agree that over time, populations will diverge genetically.
Right.
If populations are separated. If given enough time, if the genomes are so different that they can't even be fertilized in a lab, will there come a point where those genomes can no longer be compatible?
Yeah, I can jump in. Yeah, of course. See, the thing is though, if we were to test in vitro, then two species that have diverged from a common ancestor to the point where they're no longer genetically compatible, or there's some type of difference there genetically or physically that doesn't allow them to reproduce, I think the answer is pretty straightforward, that yeah, in the wild, in natural settings, they're not going to bring forth, but in vitro type situations, artificial insemination, I mean, there's probably a good chance that they're going to be able to bring forth. Because I mean, that's what evolution says. These populations diverge; they become genetically altered to the point where, boom, there's a new species. Like I understand how evolution works.
So what you're saying is, no matter how much time, if we hypothetically gave 1 billion years to two separate populations, no matter how much their genomes diverge, they'll still be able to be reproduced, to be fertilized in vitro. Is that what you're saying?
I would say that would probably be a reasonable prediction. Like, I mean, you know, I know that they've tried to do in vitro with chimpanzees and humans, as disturbing as that is, and they've had no luck in doing so. But I mean, theoretically, see, here's the thing. So your question is, so our model is the created heterozygosity hypothesis. Okay, so when we look back in time, we're looking at an expansion of the genome. As compared to the evolutionists, they're looking back billions and billions. That's what it comes down to. Theoretically, you know, populations may diverge to the point where it's going to be difficult for them to reproduce. That's why our definition is based on organisms that descend from the original ancestral gene pool, not strictly reproduction. But if those ancestors, Adam, and I'll explain this real quick, you can take as much time as you want, if they were front loaded with millions of heterozygous DNA sites, okay, and stick with me, just picture this. This is compared to the evolutionist that says those DNA sites resulted from mutations over time. And I think we're on the same page there, okay? So ours is a different explanation, but this means that the mechanisms by which new species originate can occur simply by genetic recombination and gene conversion. And of course, you have to isolate the population. Genetic drift is involved, migration, all these things. I'm just saying mechanisms wise that can produce variety, because those genetic mechanisms, if the differences are already built in, Adam, they can literally lead to new nuclear chromosome combinations rapidly, even as rapidly as each generation. But here's the answer to your question. Since the created heterozygosity events will decrease in time. For example, if you look at the horse species today, they have an abundance of homozygous DNA sites. You know, we are speciation events are reaching walls. There's less speciation events now because there's less genetic potential, because we look into the past at expansion of the genome that is now decreased. Now we've gone from more heterozygous gene sites to more homozygous gene sites. So if we go 1 billion years into the future, well, that combined with genetic entropy, there won't be any, we'll see extinction. You know, it's the exact opposite expectations of evolution. There is no theoretical billions of years from now in our model. For your model, yeah, maybe, but not our model.
So I think you've moved a little bit away from the main point, which was things remaining within the same gene pool there. How do you explain ring species?
Right. So I'm saying I'm not against ring species. I'm not against, you know, rabbits or species of squirrel that have diverged enough genetically, you know, more morphologically. I mean, that's why I brought up the finches. That was a testable prediction that Nathaniel Jensen made that was observed, I think it was 2017. New species was formed based on shifts from heterozygosity, which is what our model says, to homozygosity, subsequent inbreeding, and isolation led to new species. But if with the rabbits, or like the ring species with the rabbits and the squirrels, for example, yeah, maybe in a natural setting they can't reproduce, but we can do tests genetically, whether it's in vitro or if it's DNA barcoding, or we can look at certain taxonomically restricted genes or even function. We can determine if they have descended, which is our definition, from the original ancestral gene pool. Reproduction is a factor, yes, but it's not the only factor, because I do agree some species can diverge and maybe they're not reproducing naturally in the wild. I agree with you on that.
My big problem with your definition for kinds is, oh, I got my Alexa telling me a message. Where was I? Your definition depends on whether things can essentially reproduce or produce fertile offspring, whether it's naturally or within a laboratory. We know that genomes, and I know Rawmat's admitted, that genomes diverge over time if they're separated. We also know that things stop being able to reproduce if their genomes are too different from each other. How then do we define kinds if we know that sometimes these things are no longer able to reproduce, that they're so genetically different that we couldn't reproduce them even in laboratory settings? Because then you cannot define kinds reliably.
Right. So as I said before, my definition, or at least a kind, is groups of living organisms that we can look at. We can determine if they belong in the same created kind if they have descended from the same ancestral gene pool. It seems like you keep going back to just reproduction, but I'm telling you that there's more ways to determine ancestry. I mean, for example, in Darwin's day, his contemporary was Mendel, and Mendel did his pea plant experiments, and he looked at inheritance, Mendelian genetics, for example, recessive and dominant, genes and alleles and things. But the thing is, they didn't even know anything about genetics. So he was just looking at anatomy. He was looking at maybe the fossil record to determine, what's related, what's not. Nowadays, we have genetics, and genetics is where we can determine. It's the only direct method of determining ancestry. A fossil is not passed on, sperm and egg, for example, genes, traits, and genetics. So yeah, reproduction can be a way to determine what a kind is. But if there's been some divergence in genetics that has, unfortunately, if we can't in vitro everything, and just in the natural, there's some ring species, some species that can't reproduce. Well, now we have to go to the next step, which is, and I don't want to list them all over again, but it would be in the genetic realm. But you need to know that speciation is occurring due to shifts from heterozygosity, so more genetic diversity, to lower genetic diversity, which means eventually you're going to reach walls, you're going to reach barriers, you're going to reach limits. Evolution can't have limits. You're going to go from a single-celled ancestor billions of years ago to all the life we see today,
So what about polyploid speciation then? Where the genome is duplicated, or at least regions can be duplicated.
Right. So yeah, that's another good question. You have all good questions. So I would say gene duplications, for one, are rare events. Secondly, polyploidy. It's like, for the audience sake, to keep it simple, if a lot of this is going over people's heads, have a book, and if you were to duplicate that copy of the book you already own, well, now you don't really have anything meaningful. Now evolution would say, okay, now you're going to get mutations and alterations, frameshifts, for example, in that duplicated gene, or some whole genomes duplicate. But the thing is, that's like adding typographical errors into that second copy of the book you already own. It's still going to be deleterious. For one, duplications are rare. Gene duplications are generally lead to disease, and they're detrimental. So I don't think that that's any help, but it is a mechanism, I agree. But like all beneficial mutations, if you can show me a duplication that is beneficial, it is going to be, it's going to be reductive in nature. So that's my answer to that.
I believe a lot of the plants that we eat are a result of polyploid mutations. For example.
Oh yeah, I would agree. I mean, the thing is, a lot of the plants too, and Matt can speak to this well, especially because this is kind of his forte in his field. But a lot of these heirloom plants, and then a lot of the variations that have been artificially created from them, the heirloom plants are a lot, obviously they got way more genetic potential. That's how come you're getting all these different plants from that heirloom plant, but they're also a lot more healthier in the wild. Matt, did you want to speak to that one?
Sure, if you just think about it like an animal, right? If you take a dog and you take it from a wolf, and the wolf had more variety, and now all of a sudden you create a little chihuahua, if it has a bunch of recessive genes, it can only ever from then on produce more recessive offspring genes. The same thing tends to happen with plants. The only thing is now we're genetically modifying. So now we're twisting things around. But in nature, you're just going to get hybridization. And hybridization is a very similar process because things will cross and then their genetic potential gets a little bit dwindled with each time. So that's why heirloom is usually the best. And it's usually the best for people as well. They tend to be a lot healthier as well because when you start genetically modifying things, people are doing it for flavor. So you get like the cherry tomatoes, which are a lot sweeter. You know, you get corn that can grow in cold places like tomatoes. You know, you're tampering with things, but you're limiting its potential just so it can grow in either a particular condition or taste better.
So what I get from this is that you're saying, yeah, there are these mutations, but they're always negative. Is that what I'm getting from this?
Oh, they can be neutral, but most of the time they're limiting in factor, right?
Do you accept that there are positive ones, though?
Right. For example, when we look at the genetic database and we see 6,000 new mutations every 3 months being added, we know that there's a problem because supposedly there's supposed to be beneficial mutations outweighing these negative ones. And we see every cancer that you can name can be tied to a form of mutation. Where are these mutations that are preventing these things from happening? They're not coming up. They're not anywhere to be seen. We're only getting more damaging mutations being introduced. None of these beneficial ones. All these beneficial ones are being overridden by epigenetic regulation. Every time they think they find a new one, oh, it's lactose. Oh, no, it's not. Oh, guess it's just epigenetic. And that can't change a gene whatsoever, only the way the gene is expressed. So all these beneficial mutations that evolution needs are just wiped out. They're just gone.
Then that's where natural selection comes in. So yeah, there are more deleterious and neutral mutations than there are positive ones. But that's what natural selection acts upon. And if there are even just a few positive ones, they will be maintained within the gene pool.
Oh yeah, no doubt. That's where the theory of evolution comes. You only need one, and one will override the other 20. The only problem with that is experiments aren't showing that. For example, when they went into the Grand Prismatic Springs in Yosemite, they scooped down and pulled up 4 different organisms, and they took these bacteria back, and these are the most primitive ones on Earth, right? And they tested them. They threw them in multiple different scenarios. They threw these in a lower acidic environment and they tested for beneficial mutations. Nothing happened. The only change was epigenetic. They did the same thing with eukaryotic organisms because eukaryotes are what we are, right? So they took yeast and they put them in 5 different environments. At the end of 1,200 generations, the only thing that happened is they lost genetic information. All the beneficial mutations were just non-existent and everything was epigenetic. I like the study so much, I just threw it right into our book and made a video on it. Is incredible because they need evolution to be true for beneficial mutations, and they can't even find them in the most primitive organisms in these experiments. The only thing that ever goes up is fitness, and that's because of epigenetics.
I can think of a few beneficial mutations off the top of my head. I did mention the muscles in dog eyes that causes puppy dog eyes. That came about shortly after we domesticated the dog. Is that not positive?
Muscles in the eyes. I'm not sure. I have never heard of that mutation.
They are muscles that give the dogs the ability to do the puppy dog eyes, which we respond to as humans. And they're not present in wolves or some of the more primitive domestic dogs like huskies, for example.
Well, muscles can originate. Or, there's, for example, there's muscles that have been disappearing in the human being. There's one in the wrist. There's one in the neck. There's one that's particular in the knee. I forget the name, and humans are starting to lose this one. So I would imagine one day if we start regaining it, or if they found it in people, they'd be like, "Look, we're gaining a new muscle." Perhaps something like that is happening with the dog. I don't know. It just
Matt, couldn't that be, maybe you can expand on it? Couldn't that even be compared to maybe the Italian wall lizards and their the muscle that was I guess an example of phenotypic plasticity or something to do with epigenetics? Could that be compared to that? Wasn't that involved a muscular enhancement in the wall that allowed them to digest things that they previously weren't digesting before?
Right, exactly. They were vegetarian. They started eating plants, and they needed to slow the process of plant material through their colon down. right? Because they need bacteria to digest plankton rather than acid. So this new mussel appeared, and they said, wow, look at this. It's never seen this before. But when they went back to the mainland, they actually found that all the lizards that ate plants there also had it. So it comes and goes when it's needed. So maybe these dogs just needed it, and they just started manipulating people with it.
So you're saying the wool? Oh, what was that? Something crashed.
Oh
no problem. It was my kid's toy. Keep going.
So are you saying that the dog kind that was around on the Ark had these puppy dog eye muscles?
I think only wolves and a fox were probably on the Ark, but what do you think, Standing?
Because wolves don't have it.
Yeah, I would say if those if that information was there for the so-called puppy dog eyes, I mean, I'll have to look into that exact example, but that's why I'm looking at other examples that we do know more of, like the Italian wall lizards. We can see a lot of examples of phenotypic plasticity or just environmental related changes where that was already in the potential of the genome, to take place. I mean, are these puppy dog eyes, are they beneficial to them? The muscles?
For manipulating people, yeah.
There you go.
Right. Well, it's kind of like a lot of people say, well, what about blue eyes? That there's a so-called neutral mutation. Blue eyes look good, but the data on blue eyes, for example, suggests, and a lot of people don't know this, that people with blue eyes have more susceptibility to light sensitivity and other eye-related diseases. So usually there is some type of detrimental effect to these changes, and I would predict that if I look into these puppy dog eyes or the muscles that you're talking about that was beneficial, I can almost guarantee that there's probably something negative associated with it. But even if, and I always say this to the evolutionists too, because there are examples that you can give. Oftentimes I'm given like the example of the notothenioid fish that supposedly evolved proteins in the Arctic to keep them from freezing. Examples like this. But the thing is, even if we gave you, Adam, or the evolutionists, one or two beneficial mutations that are truly not deleterious. Picture it this way: if the whole genome is degenerating based on all these, nearly neutral mutations, the detrimental ones, for example, but natural selection, I can get rid of some of the detrimental ones. But while the genome's degenerating in all these other ways, and while a few nucleotide sites may be improving based on a couple beneficials here and there, huge numbers are still being degraded. So it comes down to a trade-off. I've debated Dr. Stefan Frello, and that's what he said. He said, well, it's a trade-off. It's beneficial in some areas, detrimental in another area. But the question is, Adam, is that trade-off sustainable? Because we can see in experiments, real-time experiments, that let's say Lenski's bacterial experiments, for example. Well, that type of trade-off results in shrinking functional genome sizes. So you're throwing out all this information from lots of nucleotide sites, and then you're trying to replace all that information with one single desirable, let's say a point mutation or a gene duplication. The fact that most beneficials are reductive anyways, the trade-off just won't be sustainable. And we see that in Lenski's experiments. So, I understand that that's the philosophy of the evolutionist. I just don't think that it's demonstrable or empirical.
A lot of what you've said over this last part of the conversation has come down to your ideas of genetic entropy, essentially, which I say again is almost like a plaything of creationist organizations. It's not something that's taken seriously in modern science. So for you to constantly go back to this assumption that genetic entropy is just happening and therefore it explains all these things, well, no, you haven't explained that explanation, so you can't use that.
We've got a multitude of papers. You can look at the genetic database. I think Matt iterated that earlier, maybe in the other dialogue. You can see how many diseases, thousands of diseases are added every single year. You can see that there's papers after papers of genetic diseases. Cancers are skyrocketing. Even the fact that these beneficial mutations, anyways, most of them are now known to be reductive. There's paper upon paper. I can send you papers right now that prove that a lot of these so-called pre-humans, Adam, that the evolutionists will point to as our ancestors, or even our cousins, like the Neanderthals, for example, the Homo floresiensis, which is the hobbits, or Naledi, Erectus, Heidelbergensis. I've got paper after paper showing that these so-called primitive humans were not primitive humans. They were highly degenerate modern humans, because it's shown that they're highly inbred due to genetic mutation accumulation. And this inbreeding, this reductive evolution, resulted in their reduced brain size, reduced body size in some cases with the hobbits, the pathologies that are seen. Mammoth populations, I got a paper here that shows that they were highly inbred and they carried an elevated genetic load, leading to their extinction. Lenski's experiment, which we can look at today. Viruses, the H1N1 virus, for example, there's a paper, and it's not published in a creationist journal. It's published in a secular journal from Dr. John Sanford and Robert Carter. He showed that the H1N1 virus went from a red hot pandemic to a whimper to an extinction event in 90 years, based on a linear accumulation of mutations, genetic entropy at work, he demonstrated. So, I mean, I could probably give you 10 papers right now showing the validity of genetic entropy. Take your time. I talked a lot there.
Again, you go into specific species. We need to see a universal trend. You can find any phenomenon in any number of species. So whenever you talk about genetic entropy, you always talk about humans, which for a long time now have essentially bypassed natural selection, which is a thing that gets rid of deleterious mutations and adds positive ones. Well, not adds, but it accumulates them. A lot of these genetic entropy experiments, or things that I've seen, are on domesticated animals, which go through the same process. So you can take specific examples and say this phenomena applies to that, but that doesn't show a universal trend. You need to show that this is universal for it to be seen as a universal trend. You can't just say we found it in these two, therefore it applies to everything, because that's what you're doing.
Well, mitochondrial clocks are one way that we can do these things, right? So we want to know the mitochondrial rate in different things. Have you ever noticed that when it's pinned up against phylogenetic methods, that they differ by orders of magnitude? A huge difference. Like everything shows that everything should be hundreds of thousands of years old, yet the observed trio studies all get thousands of years. So they're complete contradictory with each other, the observed and unobserved. And
you're saying that mutation rates are inconsistent?
Well, I'm just saying that the mutation rates themselves all show in everything, doesn't matter what it's tested, that it's faster than the assumed phylogenetic method. So that is a mutation rate that they're looking at. That's how they build those charts. When you're looking at what a mutation is, that's one of the ways we can show genetic entropy in rabbits, alligators, shark, snakes, your favorite. We would look at the mutation rate, and then boom, we have a genetic entropy from that model as well, because it's all faster than the assumed evolutionary model.
I don't think what you said implies that everything has genetic entropy.
Well, if you wanted to test how old a species is, let's say that they want to know how old a new snake is, for example, they might go, well, what's the mutation rate of this new snake? Maybe we can test it. And they look inside of it and they go, well, it's building up 100 new near neutral mutations every generation, right? So that way they don't have to look at detrimental or positive. They just test the junk, basically, the neutral ones. And they go, okay, well, it seems to have a compilation of 18,000 total in it. So they knew when that species arose. So that way we can look and go make a mutational rate clock out of that, because if every new generation they acquire 100 new neutral mutations, we go, okay, well, now we know what mutation load is. So now out of those 100, how many are detrimental and how many are positive? Well, they show that as well.
So when I did my genetic analysis of cobras, I put it into something called MEGA, which looks at mutation rates, differences in certain parts of the genome. And it measures all these cobras against each other. There was also an outgroup of vipers. And it measured at millions of years difference. So are there several kinds of cobra?
What was the method you used?
It's just straight DNA. You look at the differences in the genomes, or the genes that we analyzed, and you look at the differences between them. And you take mutation rates of the snakes and you apply that into it. you put it into the test, and it comes out with a phylogenetic tree, which shows you roughly how long ago they were related, and in order of relation.
Oh, okay. Well, you said
how they grouped.
I see. So you said it right there. It was a phylogenetic tree. The phylogenetic trees take evolutionary assumptions and add it in. So they assume what happens is the snakes split from a lizard, and they believe that this happened around 200 million years ago. So what they'll do is they'll add the mutation rate and extrapolate it like they did.
No, you don't put any supposed dates in there. All you put in is mutation rates and the genetic data.
Well, it seems to be different with humans. For example, when they take...
Well, that's the thing. It's got to be universal. It's got to be everything. That's what I'm saying. You can't just say this specific group have a common ancestor of so long ago. You're saying that everything went through a bottleneck at exactly the same time, 4,500 years ago. Therefore, everything has to have that bottleneck. Everything has to have arisen at that time. So proving that anything doesn't line up with that eliminates it as an option.
Well, that's actually what the CO1 gene barcoding actually did show. It actually did show the little genetic diversity. So it's a little bit different. The mutation rate that you were doing to build your phylogenetic tree, for example, when they were building it with mitochondrial Eve, they said, well, if we just look at trio studies and we know that she's inheriting, let's just say 100 new mutations every generation, and we take that back, it arises just a few thousand years ago. But what we're going to do is, because we know evolution is true, we're going to add the 6.5 million years when we believe they were related to chimps, and we're going to add it in, and that's called the phylogenetic method. Well, the same thing is probably happening with these animals as well. They see the rate and it doesn't match what it's supposed to, so they extrapolate the phylogenetic assumption and into the models, and there you go, you get your millions of years.
So how do you explain my analysis then, where I didn't put any dates in? There were no supposed dates put into it.
I find that
DNA samples from a whole host of cobras from Africa and Asia, and we compared the genomes. And from those comparisons, the number of differences between them, the estimated divergence time was in the millions of years.
That's strange, because we know that reptiles actually have some of the fastest mitochondrial clocks on Earth, even faster than humans. So if humans are showing to be about 6,000 to 7,000 years old and reptiles are not, that makes me suspicious about what's going on, because reptiles do have the fastest mitochondrial clock inside of them at all. I'll show you the study.
So how would you respond to that then? If
Adam,
the analysis comes to millions of years?
I'll respond to it. So with those snakes, are you doing the phylogenetic analysis based on the gene sequencing of mitochondrial DNA or nuclear DNA?
There were two genes from mitochondrial DNA. One of them I know was cytochrome B. That was definitely a mitochondrial bit of DNA. I think there was another one. There was NT3. I could go and find them, but I can't think of the rest on my top of my head. I know that NT3, cytochrome B. Can't remember the other ones off the top of my head.
So you're using conserved mitochondrial genes?
We were using a variety of genes, but the best thing about that is that you can get, instead of just doing one gene where there could be a problem or that particular gene goes at a different rate, if you take a whole host of different genes and analyze them, it gives you better accuracy. So we took, I believe from my experiment, it was 5 different genes, and they pretty much all came up with the same answer.
Right, but it's all mitochondrial genes you're looking at?
No, there were some mitochondrial and some nuclear.
More mitochondrial genes than nuclear?
There were more nuclear ones.
There were more nuclear?
Yeah.
And then how do you explain the origin of nuclear DNA differences?
The origin of nuclear DNA differences would be mutation.
And then how do we explain the origin of nuclear DNA differences?
How do you explain it?
Yes.
I imagine mutation.
Well, no, and that's the thing. Like, we don't want to talk past each other. That's why I always try and clarify with our created heterozygosity hypothesis. The nuclear DNA we're saying was front loaded. The vast majority of nuclear DNA is the result of divine creation. Okay, so that's why processes like recombination, gene conversion, okay, on these front loaded nuclear DNA differences can result in new chromosomal combinations quick. So you're assuming in your phylogenetic analyses there that all those nuclear DNA differences that you're looking at are the result of mutation over time. Do you know the mutation rate and speciation rate of the particular snakes you're looking at?
Certainly not off the top of my head, no. I did this study a few years back.
Well, and that's kind of what Nathaniel Jensen's doing, is he's making specific predictions on mutation rates and speciation rates in animals that have not yet been measured.
I'm taking the challenge to them now and saying, hey, let's go out and there's a fox in the woods. I bet you I can tell you how fast his mutation rate is.
So, I mean, we'd have to look at like how many snake species, for example, on this planet right now.
On this planet, a few thousand.
So, I mean, a few thousand snake species from a handful of snake kinds off of the ark is easy to explain. But like, how come there's not? So, for example, let's say birds and snakes or even lizards. So birds have like 11,000 species, 12,000. Snakes, let's say 3,000. That's consistent with our model, you know, of these species coming from a handful of kinds off of the ark. But according to, let's say birds, for example, you say birds evolved from dinosaurs, you know, theropod dinosaurs millions and millions of years ago. Why are there not hundreds of thousands of bird species, or why are there not thousands and thousands of snake species?
Because either there's no need for speciation in large populations, or there's a large extinction rate, or a combination of the two.
But then you said in the last discussion and debate, you can't make predictions on speciation rates because there's so many variables and factors involved in it.
Yeah, I know.
So a lot of what you're saying then will just have to, unfortunately, be the result of inference, storytelling. Because if there's no testable predictions that can flow from that explanation, well, then it's not science. Like I know with mitochondrial DNA, a lot of evolutionists will say, well, you know, natural selection filtered out all the mitochondrial DNA differences that arose in the millions of years to overcome the 6,000 year explanation and empirical evidence for mitochondrial, even mitochondrial DNA. But the thing is, you'll ask them, okay, well, what testable prediction can you make? You know, what's the mutation rate then for the Khoisan peoples, for example? Because Dr. Jensen made a prediction on the Khoisan peoples, and they'll say, well, you know, there's too many variables, too many factors. But where they're saying there's too many variables and factors, we have scientists like Dr. Nathaniel Jensen actually considering those and making direct, very precise predictions. I mean, we'll see if they come true, you know, on the Khoisan peoples in the future, but that means it's science. Science has to deal with, you know, that which is testable and that which is falsifiable. I just think, you know, a few thousand snake species, that's easy to explain according to our model, but millions, and I mean, the oldest snake species in the fossil record, how long ago was that? Like fossil-wise, like 150 million years or something?
667 million years.
Wouldn't you expect more species then than just a few thousand?
Not necessarily, no.
Because of the variables and factors you were saying. Because a big point with all this too is, you know, 11,000 bird species, a few thousand snake species, 4,000 or 5,000 lizard species, coming from, or 30 cat species, for example, you know, coming from a handful of ark kinds just 4,500 years ago is easy to explain, especially based on our model of, you know, pre-existing genetic diversity. But yet the evolutionist wants us to believe that all these different species came about from a single-celled organism long ago and far away, billions and billions of years ago. I mean, that is where the imagination lies, it seems. It seems like our model is stronger when it comes to the species.
I disagree entirely.
I did want to ask.
I don't want to go too far from the point because I don't think I've had a satisfactory answer. How would you respond satisfactorily to studies saying that these animals are they've diverged over millions of years, like the cobras, for example? Are you saying there's more than one cobra kind? You've said
I did explain that.
Yeah, you said the what was it? Hetero. Can you give me the phrase again?
Well, I'm just saying that if you're doing a phylogenetic analysis based on the assumption that those nuclear DNA differences that you're looking at are the result of only mutation over time, well, yeah, you're going to get similar analyses. That's why Dr. Jensen's making specific predictions under the assumption of his model, of our model, the created heterozygosity hypothesis. Now the mitochondrial DNA, yeah, that's based on constant mutation rates over time. So if the snake phylogenetic analyses you're looking at is showing that you said it was the cytochrome B in the mitochondria that you're looking at, and that revealed mutation rates and DNA differences in the mitochondria consistent with millions of years, or was it the nuclear DNA that revealed that?
It was all of it.
All of it in combination.
Essentially, yeah. They all match up. You test them separately, and then you put them. You basically compare them.
Yeah, exactly. So with the mitochondrial DNA, if you're just looking at that and not considering the nuclear DNA in your phylogenetic analyses, what is the origin of the mitochondrial DNA? Is it thousands of years? Is it 100,000 of years?
Millions of years.
If you just looked at the mitochondrial DNA.
Yeah.
I'd have to look at what the actual, because I know that the nuclear DNA, for example, let's say for humans, seems to go back coalescence wise, millions and millions of years. But that's based on the assumption that all those nuclear DNA differences are the result of mutation and not created DNA diversity. The mitochondrial DNA in humans, though, does go back 6,000 years, because we explain the origin of mitochondrial DNA differences for the most part as mutations over time. So if the snakes that you're looking at in this phylogenetic analyses in the mitochondrial DNA alone is going back millions of years, I would just have to see, or even ask you if you know offhand, what is the mutation rate in those snakes you're looking at. I can't make a valid judgment if I don't know we know the mitochondrial mutation rate in humans, which is why we can make direct predictions on human groups that haven't been measured. But what's the mitochondrial mutation rate in the cytochrome B gene that you're looking at in the snakes?
Again, I can't recall off the top of my head. I did it a while ago. I haven't looked at the paper for a while.
Because snakes is your expertise, I'm actually just curious because I appreciate your knowledge on it. From my understanding, there's two mutually incompatible theories of snake evolution. From my understanding, some say that they evolved from water reptiles, right, mosasaurs, or others say from burrowing lizards. Like, which one do you hold to?
There's a reason it's very controversial.
That's it. Look, you can take your time and you can have the floor and explain.
I personally suspect they were burrowing animals, much the same way that lizards these days are losing limbs and becoming very snake-like, and they're burrowing animals.
What would the people or the evolutionists that hold to the theory of, because you said that you believe that they evolved from the burrowing lizards?
Again, it's a controversy because nobody really knows. But from what I know, I would go 60-40 in favor of burrowing.
You would, okay. And then the ones that hold to the theory that maybe they evolved from water reptiles, right, the mosasaurs, what would be their disagreements in regards to the burrowing lizards?
I think it's very much lifestyle, and you do also find a lot of fossil snakes that were aquatic. Najash, for example, I believe was. Oh no, not Najash. I can't remember. There's all the Latin names, and all rather complicated. But there are a few fossil snakes from very early on that were aquatic.
Okay, so so you hold to the theory that they evolved from burrowing lizards then?
I don't hold to it.
Okay, I get what you're saying. So like you would say the evidence 60-40 leans more towards that one?
Personal opinion, yes. There'll be a lot of people that disagree with me, but that's what I think.
Okay, so we know, and I don't have to go over all the differences, but we know snakes are very different from lizards. What kind of mutations would you say were responsible for transforming those burrowing lizards into snakes?
Well, the things that really define snakes is not leglessness, because obviously there's a lot of lizards that are legless that you don't call snakes. Most of the differences you'll probably find are in the skull. They've got quite a derived skull compared to a lizard.
Right. And the jaw hinge, like I know snakes have fangs and a flexible jaw hinge, whereas lizards have, I think, flat teeth and immobile skulls, right?
Yeah, the snake's skull, it's separate on the lower jaw and it spreads out. A lot of people think they dislocate, which is complete rubbish.
What about like the fact, like with movement, for example? I know lizards move by, I think they twist their stiff body or even use their legs, but the tails of snakes are totally different. They're short and they don't break off when grabbed. You said you own a few snakes, you would know that. In comparison to lizards, they've got the longer tails that can break off if another animal grabs it.
Only some lizards.
Pardon?
Only some lizards.
Only so some lizards are you saying would they be more comparable in tails to the snakes?
Geckos, for example, are a group that can drop their tail.
But they're still far different than like snakes. They use their tails are short. They're mechanically far different than you said geckos?
You get short-tailed lizards as well. Just look at the Uromastyx, for example.
Right. So are you? So you're more so looking to like the skull morphology and things like that versus
what defines snakes from lizards is mostly in the skull.
Is mostly in the skull.
Yeah.
Because I know like snakes, don't they move? Since we're on movement, don't they move by gliding and they use the bottom scales on their body?
There's a lot of different ways that they move around. Some of them have the S pattern that you see in popular TV and that. They move their body from side to side in order to have forward motion. Some of them move almost like in a straight line by movements of the ventral scales and the muscles below them. And then you've got things like the sidewinder, which just fling themselves. There's all sorts of different motions for how snakes move.
Don't like one that I'm curious about, like for example, not only do snakes have fangs and a flexible jaw hinge, where the lizards, as we were discussing, have flat teeth and immobile skulls, but you're saying it's in the skulls that we would look at for the defining features. We know some snakes have heat pits on their nose, but then they also have no external ears. Lizards, on the other hand, lack heat pits, but they do have external ears. Like, how would you explain that difference? Is that something that just evolved over time that we can see in the fossil record, or is that something that's inferred to have evolved?
Well, you mentioned that only some snakes have the heat pits. So you've got snakes that don't have heat pits. For example, all the snakes I own, none of them has any heat pits. So I don't see where you're trying to go with heat pits.
Well, I'm just, I guess, going over a lot of the, because even if like some snakes may have this and some don't, or with lizards, with the tails, some may have a shorter one, but there still are these defining features that would need to be explained evolutionary wise, how that burrowing lizard evolved into a snake as we would know today. And it seems like a lot of the evidence, especially from the fossil record, involves things that are lost, right? Legs, for example. So my question would be, how does loss of genetic and anatomical structures to you provide substantial or sufficient evidence for that type of evolution that would say burrowing lizards evolved into snakes over time?
Well, could you repeat that in fewer words, please? I'm trying to get the point of your question.
How does loss of genetic and anatomical structures provide evidence for lizard to snake evolution?
How does loss of genetic information provide evidence for lizard to snake evolution? Is that what you're asking?
Yes.
Well, that's not really the thing we looked at when we said that snakes were derived from lizards. We didn't look at genes and say they've lost genetic information, therefore they evolved from lizards. It's different things.
I know, but what I'm saying is, in the fossil record, for example, what we look at is snakes. You're saying that they evolved from lizards, but then the fossil snake species we see that actually have like those, I guess, hind legs, you could say. It looks like the further back, the furthest back you can go, the snakes you find, they don't have any legs. And then you can find some snakes with legs 50 to 100 million years later.
Yeah.
And then, but it should be like the reverse. Like why, I guess based on your reasoning, and because I imagine that the differences we're talking about and how those changes would be required, we can infer from the fossil record. But snakes. So you're saying snakes would have gained legs, and then like I see reversals in the fossil record. Like how do you explain that?
This is a fundamental misunderstanding of how evolution works. You get a population of snakes. Now, the original snakes would have had legs because, as I mentioned, leglessness isn't the defining characteristic of snakes. It's in the skull. So the original snakes would probably have had legs. You would then have the divergence of these big groups of snakes. You find it when there are adaptations, there's usually radiation where you get masses of groups of these animals and they spread across large areas of land, maybe even across the globe. So back millions of years ago, say 200 millions of years ago, you probably would have had snakes in various parts of the world with legs. Over the next millions of years, some of those groups of snakes would have lost their legs. Some of those snakes might have been fossilized, and that's like the ones you see in the fossil record. So you've got legless snakes showing up in the fossil record. You've still got snakes with legs living elsewhere in the world that either went extinct later on or lost their legs later on. And you still get some of those legged snakes moving on through the years and to the point where, say, 20 million years ago, you still had snakes with legs. It's not... the snakes didn't all evolve as one single population. The snakes would have radiated as snakes with legs into multiple populations. Some of them would have become legless long before the others, or some of them may never have stopped being legless and just gone extinct and left only the legless snakes. So to have the earliest fossil snakes we find to be legless and some legged snakes to be found later on in the fossil record isn't a problem at all.
Right. So it's just because my point is, like, according to our model, of course, and as I've said many times, it's genes that are inherited. I think genes is where we can directly determine, what's related, what's not, the origin of these traits in regards to, let's say, the lizards to snake evolution. We do see snakes with no legs. We see snakes with the the hind legs, for example. But according to our model, those layers. Yeah, those layers are not, they are not absolute ages of time. So it looks like the evidence would suggest, either the snakes with the hind limbs are used, as we can see today, for copulation, reproductive purposes. I think for clasping during reproduction. Like, would you agree with that function, or would you say that they're completely worthless, the hind legs?
Trying to think, because there's quite a lot of groups of snakes that still have it, and I believe it varies between species.
Because I'm trying to, like, the ones you see with hind legs in the fossil record, they could either be, like today, used for reproductive purposes as a function, or like, for example, Najash, is that the name of the...
That's a two-legged snake, yeah. It's got two hind limbs.
Isn't that and that's a genus of snake, right? Najash, like there's many species in that genus.
Yeah.
So that snake has the hind limbs on the side of its body, though, right? Versus it's coming from the side of the body, isn't that? I remember you pointed that out before.
Yeah, that's you won't find lizards with legs below. They're always side.
Right, and that's like a defining trait in that in the fossils of the genus Najash that you would point to that say, okay, here's your two-legged snake. That would be your transition between your burrowing lizard to your snakes with legs.
Not necessarily, no. Because, as I said, leglessness is not the definitive characteristic of snakes. It's in the skull.
Right. Are you familiar with I think it's the HA1 gene for back legs? It's in a non-functional or degraded form in snakes. That's why sometimes you can see snakes that are born with these useless legs that don't actually function because that gene is broken, suggesting that there were some species of snake in the beginning. Like according to the Bible, right, the serpent was cursed. And that serpent would have had legs. And if God, through epigenetic purposes or just, the damaging of genes, like we see with this HA1 gene, it was a process over time that these snakes would lose legs based on the degradation of that gene, for example. I mean, that's consistent with our model of snake species. with some legs like Najash, for example, that have lost them over time, and snake species like the furthest snake species we can see in the fossil record that have no legs at all, or just basic hind limbs that sometimes evolutionists will say are vestigial, but they're actually used for reproductive purposes. So that would be, I think, pretty consistent with our model. Take your time. Yeah, go ahead.
It's interesting what you brought up there. So God would say, "Be gone with your legs, snake." How did it work there? Was it instant or was it over time?
Good question. Yeah, I'm proposing theoretically that it was over time, because you can see that specific gene for legs, for the back legs, is degraded, and it is in a non-functional form. So if God, because it says God cursed the serpent, so if those genes were, because you've got Garden of Eden, you've got the serpent, but you've got also outside the Garden of Eden, you've got snake species that theoretically, like Najash, would have the hind legs, that they would lose them over time. Yeah, I don't think they lost them right away. No.
Do you think all the fossils of snakes were caused by the Noah's flood?
I would say that the majority, like for example, the ones that are found 100 million years ago or 150 million years ago, for example, like with Najash. What's Najash? 100 million years ago that they've discovered that one? Because you would say that snakes evolved from lizards 200 millions of years ago, right? Was it during the Jurassic period, maybe?
It was around the Jurassic, yeah, I believe.
Yeah, okay, so let's say,
the oldest fossil snakes we have are that long, but the genetics, yeah, goes back further, obviously.
yeah, okay, yeah, then yeah, they would have been fossilized during the flood. That's right.
So there are some snakes in the fossil record that have legs. Some have 2 legs, some have 4 legs, some have no legs. So after God punished them, some of them lost their legs at quicker rates than others.
Yeah, that's right, because I'm saying that God would have cursed, if they're going to lose their legs, and we see that there's this gene, what is it, the HA1 gene, I think it's called. Hope I'm not butchering that. I can look it up. But that is in a functionless form in snakes. We can see that today, sequencing their genetics. The snakes we see in the fossil record, they're just bones. So, we can infer the best we can, but we don't have any genes. We don't have a bone, like I said, it's not passed on sperm and egg. I think that's an appropriate inference, that there would have been snakes with legs at creation. We see that the serpent had legs, and he was cursed. If it was a genetic curse where over time, and like you said, yeah, maybe some snake species lost it faster than some based on environmental conditions, because we know that a lot of change is environmentally dependent. So I think that's perfectly consistent. Yeah.
Were certain lizards cursed as well then?
Good question. Yeah. So over time, we can see that there's certain lizard species right now. Are they the skinks, for example? I believe that they are burrowing lizards and they are losing their legs.
Yeah.
Yeah, the thing is, the curse at the very beginning of creation in a world with no accumulated mutations versus today in a world with accumulated mutations, legs, as you've said, or fish, blind cave fish, they would be prone to losing traits or features such as that. So yeah, I would just say that loss of anatomy, loss of genetic information is consistent with our model of genetic entropy and reductive evolution.
I will say it's hardly a curse, though, because snakes are one of the more successful species on the planet. Their leglessness has allowed them to take advantage of a whole host of environments. They can be arboreal, they can be terrestrial, they could be subterrestrial, they could be aquatic. Their leglessness has allowed them to radiate to loads of different areas, and they're very widespread. Would you still consider it a curse, even though that's the case?
So would you like, in your next life, would you like to come back as a snake that has to crawl around on its belly eating dust all day?
They don't eat dust.
Okay, well, answer the question though. Would you? Okay, well, is there a disadvantage at birth when you get that snake that is just born and has to crawl around on its belly? I mean, in the world of predators and things like that, isn't there a disadvantage there? I mean, I agree with you that any kind of species is going to be able to learn to adapt to its environment, of course, and you can even see that in like Lenski's bacteria, for example. But when those bacteria are adapting to their artificial environment as well, and yet we can see that they're doing it through lots of function, lots of traits, lots of information. So I mean, yeah, I'm not against adaptation if that's what you're getting at.
To answer your question, if I was a snake, I wouldn't mind, because that's how snakes live.
Right. Okay, go ahead. Because you're a herpetologist, I wanted to give you some considerable time discussing snake evolution. I mean, that's your field. But I did want to go back to one point before I forget it. I keep trying to keep it on the back of my head, or in the back of my mind, from when you were discussing with Matt, because you were talking about how like a universal genetic entropy. If we can see it in viruses, okay, the H1N1 virus, which has high generation and high mutation rates. What about in the long-term E. coli experiment by Lenski, which I mean I've mentioned many times, so I'm sure you're familiar with. But that work does show that, for one, the rate of beneficial mutations is less than 1 per million. And then that experiment clearly showed that most of the documented beneficials were loss of function mutations. And I think that that's a perfect reflection of what we are describing as reductive evolution, or genetic entropy. So if we can see it in humans, which you say there's a problem with because lack of natural selection, okay, fine. We can see it in mammoth populations. We can see it in bacteria. We can see it in viruses. We can see it in inbred populations, of course, because then that's just going to speed up the degeneration process. We can see it with the accumulation of disease. Is that not universal enough for you?
No. Because we've got examples where the genome isn't decreasing.
In what?
Well, for example, polyploid.
Right, but
increasing genetic information. The dog's one, the puppy dog eyes again. That's caused by a change in the genes, which results in these muscles, these new muscles.
Are you saying that wolves don't have these puppy dog eyes or the muscles associated with them in a much more degenerate form?
They don't have the muscles.
I think they do in a degenerate form that have been amplified in artificially bred dogs that have now served a benefit to some kind, I believe. No?
No.
With gene, you'd have to look into that, but that's I believe that the wolves do have it in more of a degenerate form, but we can look into that after. But the gene duplications that you're referring to, like I said earlier, are universally deleterious. There's no, you can have 10 copies of the same book and start introducing typographical errors in those extra copies of the original book. You're not going to really get anything new and meaningful. I mean, typographical errors indicate mistakes, and that's what we see with mutations. Plus, duplications are rare. I mean, I pointed out earlier, is there, other than natural selection, and based on the known functionality of the genome, the known functionality of all the genomic elements, including the pseudogenes, ERVs, the various classes of retrotransposons. I mean, they're crucial for genetic health and function. If the genome, the genetic information is nested and it's overlapping, any small little change is going to be not neutral. It's going to have some type of deleterious effect, even if it's invisible to selection. That's the point. What type of selection can you give me that's going to be able to filter out those nearly neutral mutations that are only just very subtle on the genetic content?
Natural selection.
So it's only so. But if natural selection, Adam, is only acting upon the most detrimental of mutations and amplifying a few really beneficial mutations, well, what's it going to do against the worst kind of mutations, which are the nearly neutral, very subtle mutations that are just very slightly deleterious? What does it do against? It can't see those.
If it's very slightly deleterious, then it is deleterious.
Right, but it's like a book the size of an encyclopedia. You get one single spelling mistake on its own, it's inconsequential, but the buildup of them over time degrades the message, degrades the book, and that's what we see with these nearly neutral mutations. If the genome was truly 90% junk, you've got 10 mutations that are deleterious entering the human population per person per generation. But we now know that that's false. We know that the genome is a lot more functional than that. So therefore, you've got many more deleterious mutations accumulating per person per generation. Natural selection is only going to get rid of the worst. The ones that are very subtle to fitness, like that single spelling mistake in a book the size of an encyclopedia, they will build up. That's why we see the genetic disease. I mean, you got to have a type of mechanism, or else it's just you're just hanging out in the realm of philosophy.
Okay.
Well, let's do this, because actually we went for a couple hours. It's been a lot of fun. My kids have been up for a little while. You're the guest here. Actually, there's a few other things I wanted to discuss, but for sake of time, maybe we can do a third one, because there's so many points to touch on, especially with kinds and speciation. Let's give you a few moments, even a minute or so, to kind of sum up what you think, maybe address some of the points you feel like are hanging. Adam, take your time.
I've enjoyed myself tonight, so thank you, all three of you, for being here and having this discussion. It's good to do this sort of thing when, let's be honest, we can't really do anything else. The main thing I'm taking away from tonight is that. Oh, thanks.
Attaboy, praise.
We haven't heard enough of that whatever it is that praise is playing with. A lot of it has come down to genetic entropy. And as I've said a couple of times, that's simply not an idea that's taken seriously in modern science. And because everything seems to fall down to that, and this idea of created heterozygosity, which is just asserted without anything backing it up, the fact that I'm told I have a problem with a bottleneck of 10,000 when the opposition has a bottleneck of 4, it's a lot of the stuff is just it strikes me as very vague, very much an exercise in cherry picking, and quite frankly, you haven't convinced me.
Is it okay if I ask you one question before we end it? Like with our model, right, the created heterozygosity hypothesis, if we're saying that the new species are going to arise through shifts from more heterozygous nuclear DNA to more homozygous nuclear DNA, which is what we've seen in these new finch species, for example, that would mean, according to our model, that those new species are effectively losing a number of those heterozygous DNA variants that were front-loaded in the created kind. So my question in regards to that would be that if according to our model that speciation potential lies within the ability to spawn genetically and visually diverse offspring based on heterozygosity levels, would high heterozygosity, wouldn't that indicate higher potential for speciation, while lower levels of heterozygosity would represent a lower potential to speciate? Would you agree with that?
Speciation is very much dependent on what's happening with the population regarding its environment. It's not necessarily down to the makeup of the genome. It's whether group or populations are isolated from one another and their genomes allowed to diverge.
Right. No, and I agree with that, but I'm trying to say, because you, like, a lot of it, I just want to make sure that you understand before this conversation ends. You're asking, like, where's the limits, or what happens in billions of years from now? But high heterozygosity levels would represent a greater potential for change, for allelic variety. Would you agree with that? Higher heterozygosity would mean higher potential for change in speciation, right?
So you changed things there. You changed it from allelic variation to speciation.
Well, because the higher allelic variation you have, the greater potential for change, the greater potential for speciation. If the process of speciation involves shifts from heterozygosity to homozygosity, the lower heterozygosity you have, like low heterozygosity as compared to high heterozygosity, would represent a lower potential for speciation and change. And why do we see in species today, like the horse species, for example, they have more gene sites that are homozygous versus heterozygous? Take that back to like the horse kinds off the ark, then they would have more heterozygous gene sites. And take those horses back to creation, there's your pre-existing heterozygosity. Don't you see how it's a downhill change? Like, we're looking back in time to the expansion of the genome. But evolutionists, it's the opposite. You're looking back to a single-celled organism billions of years ago. You're looking back to a contraction of the genome, because from a single-celled organism to now, fish, amphibian, reptile, mammal, monkey, bird, monkey, man, that would require the expansion of genetic information. Versus us, the opposite.
How do you know that?
Well, if you started off with a single-celled ancestor, billions of years.
How large was the genome of the universal common ancestor?
Well, you tell me. I don't know. It's your story.
Exactly. We don't know. So for you to say that I've got a problem because we need to add more information from the original common ancestor, you've jumped to that without actually providing a reason to.
Well, no, I'm not necessarily saying you have a problem. I'm just saying for clarification purposes, do you not see that it's opposite expectations? Because we're looking back in time. We're looking at an expansion of the genome. We're looking back to the creation of these kinds and Adam and Eve that were front loaded with all these pre-existing functional DNA differences. Over time, through genetic processes, recombination, gene conversion, isolation, divergence, genetic drift, all these things that lead to speciation, we're now looking at the contraction of that originally expanded genome. Right? Because you're asking about the limits. Well, I'm giving you an answer to the limits. I just want to, especially for the next conversation, that's why we reach walls or barriers in speciation potential, because those gene sites that were heterozygous, we're losing them over time.
I think you'd need to provide papers on that, though. I think you're getting that from the idea of genetic entropy. Is that true?
No, I mean genetic entropy, because remember, we explained the vast majority of DNA difference as the result of created DNA diversity. But the genetic entropy model would say, yeah, we're accumulating mutations since creation. But evolution says all those DNA differences were mutation. I'll tell you what, I do have papers on that. I'll send those to you. You can look them over. And then the next time we have a discussion, we could, I guess, expand on this conversation where we left off here.
Sounds like a good plan.
Okay. Did you have any final words before we?
I gave my final words.
Okay. Well, I appreciate you giving me the chance there to ask another question. And yeah, like you, I really enjoyed this conversation. I enjoyed discussing snake evolution. We touched a number of really good topics. So I hope the chat had fun.
Do you understand my point? I just want to clarify, because I know this is in your book. Do you understand now that because we find legless snakes in the fossil record before legged snakes, that's not a problem?
Well, I know according to like evolutionary theory, yeah, you guys would look to like loss of traits evolution, convergent evolution, things like this to explain why you would find snakes the furthest you go on the fossil record that don't have legs, and then you'll find snakes with legs. Yeah, it's just like Tiktaalik, for example. I'll point out that you found tetrapod footprints in Poland that predate Tiktaalik. Yeah. Now, I understand that Tiktaalik, you'll say, it doesn't necessarily mean that that was the first transition.
Yeah, that's why we have things as sister taxa rather than putting things as nodes.
Exactly, yes. Yeah. No, I agree. I agree with like the evolution, I guess I want to say story of it. You know, I understand that, yeah.
That's my final word, then. I'd like to see that correction in your book.
I'm not saying that, like, I'm just saying I understand the it would be almost like an evolutionist saying, like, you do understand why, you know, we expect dogs to produce dogs based on the law of monophily, right? We wouldn't expect a dog to give birth to a cat. That would be me like saying, well, no, I understand that it's genes and traits that are inherited, and of course, based on the law of monophily, you know, eukaryotes are always going to produce eukaryotes, mammals are always going to produce mammals. I understand that. I don't agree with it supporting evolution. So that's kind of what I mean. Like, I understand what loss of traits evolution is. I understand what convergent evolution is. I just don't believe that it rescues you from the problems.
Okay.
I hope that makes sense. But I do understand, like, what you're saying. Yeah, I agree that makes sense in the evolutionary worldview. But remember, we don't look at all those snake fossils in the geologic column, and we don't look at that column like it's different ages, millions and millions of years. We believe that it was all created in one year-long worldwide flood. So, but we can talk about that later. Yeah.
Right. Okay.
Okay. Yeah. Awesome. I appreciate it. I hope the audience had fun. Matt, hopefully you didn't fall asleep while Adam and I were blabbering on there. You can say final words, brother, and we'll shut her down.
No final words. It was good. I'm just here to chime in.
Awesome. Adam, like I said, it's always a good time. I hope you always feel like you got enough time to talk and that it's respectful. And we'll touch on a few things in our next discussion. So we'll hand it over to Praise for his final words, and he can shut it down.
I'd like to recommend this book on the right. It's The Variety of Life. It's a brilliant book for this sort of stuff on cladistics and taxonomy. I'd also recommend reading Raw Matt and Standing for Truth and Jason Ezard. Their book, 100 Falsifications for Evolutionism. It's a good bit of homework for anyone who wants to look into fact checking and sourcing. I think it's a good bit of homework for that.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.